and then for you guys to let us know what you need more of. So without a further ado, I'm going to introduce Judd Smith. He's been with ISCO a number of years, and he's been doing a lot of training lately, so he's really good at it. So Judd, go ahead and take it over.
Hi. As Carl was explaining, my name is Judd, J-U-D-D Smith. I'm sure my name is familiar to some of you, but maybe not all of you. I have been with Teledyne ISCO for 8 years, and about 7 of those years have been in the service department. I work on liquid chromatography units, syringe pumps, anything that we work on here in analytical service. So in my time, I've seen a few different liquid chromatography units that we sell and service. And today we're going to talk about our newest flash chromatography model, the NextGen. This banner back here gives a little bit of information and a picture. I do have a unit to kind of show you some practical examples on. But as Carl stated, I think we're going to start by kind of quickly going over the manual. We're going to go over some important links that I think you'll find very valuable. Our website is a vast wealth of information for you. But of course, we're always here to support you too in the service department. You should have our email and phone number, but if not, we can get that out to you as well. It's in the manual, how to contact us. And believe me when I say we're going to touch upon that today as well, because you need to know how to contact us. But before I really tear into it today, does anyone have any questions they're just dying to ask before we get started? All right, so we're going to get started. I'm going to do a quick screen share, and we're going to start going over some things in the manual. You should know that the manual is downloadable on our website. And our website is www.teledyneisco.com. Now in there, you'll find the chromatography section, and there should be a spot, either it says manuals, or you can go to the actual product you're looking for. In this case, it'd be NextGen. And if you scroll down, there's going to be a bar for documents, and you should have everything there, including manual. And we're going to go over the latest one that's on our website. There is a new version of this manual that I wrote myself. I didn't write this one. I wrote a new version of it that has a lot more information. We're pushing it through right now to get through all the editing process to get put up on the website. But currently today, I'm going to go over what's available to you. Okay, so I'm going to go ahead and screen share and we'll get started. All right. Okay, so what you're seeing here is the title page of the manual we're going over today. If you look, it says revision April 2020. That's how you know you're looking at the same one that I'm going through right now. What you're going to see here is just a picture of a NextGen 300 or 300 plus. They look practically identical on the outside. So what we're going to do is just start going through. Over here. All right, we got some safety warnings here. Just letting you know that there are things you can put in the unit that are harmful to you and harmful to people around you. So do take care when using this instrument. Namely, you are using flammable solvents a lot of time. So just be aware that there are dangers in using the instrument, but as long as you are responsible, you'll be just fine. Including more hazard symbols. There's electrical hazards, not many, but there are some in the unit. And there are pinch points and things like that that could cause you physical harm. Table of contents here, just kind of outlining what's in the manual. I'm sure you've all seen a table of contents before. And I should say right now that I'm going to explain some things to you today that you already know. I do apologize for that now. I know that there's a lot of things that you want today that you don't know. You're going to get those things too. But I'm going to explain a lot of things that you already know. And for that, I'm going to say sorry now so I don't have to every time. All right, we'll move on. All right, general information. This is what I was talking about before. You need to know how to contact Teledyne service. We're here to support you. So this is how you contact us. You can contact us by phone by calling 1-800 775-2965. Now, we are only available from 8 a.m. to 4:30 p.m. Central Standard Time in the US. So that might not be practical for all of you if you need some assistance. So you might want to try the other option, the email, which is isco.service@teledyne.com. And that's isco.teledyne.com. Those are the two best ways to get a hold of us. You can always bug your salesperson. You know, Philip's always available too, but Philip likes to communicate with us. And so he actually communicates with us through phone or email as well. So if you need to contact us, that's how you do it. So this manual is going to cover the CombiFlash NextGen 300 and 300 Plus. We do have another NextGen system called the NextGen, aka the NextGen 100. We won't be covering that one as much in this service training. The difference really is between the 300 and 300 Plus is there's some options for you. Injection valve being one of them, RFID readers for the racks and columns. These are all optional things. The NextGen 300 Plus has everything in it, all the bells and whistles, but the 300 has a lot of options for you to choose from. So moving on, we have the software update. You might have noticed that there are revisions to the software that you can update in your unit, and you can find those updates on our website, and it's listed there, but you go to that same teledynesco.com website that I told you about to download the manual. Everything is there for you. User manuals, they will include specifications, operation instructions, and the component wedded materials list. And that's found at that same website, teledynesco.com. Now, you may, from time to time, not be able to remote troubleshoot with us. You might not be able to repair something on your own. In that case, you have to send it to the depot for repair. That's in Nebraska in the USA. And so you'll have to contact us. We would ask that you probably do that through the website. It just makes, or I'm sorry, our email address. Just makes everything easier. That way everything's in writing. If you need to send an attachment PO, it's just the best way to do it. Now, I'm not going to hang up on you if you call me, but I will probably need to take your email address because I'll need a lot of stuff in writing. Let's see here. So if you do contact us, what I'd like to go over real quick. All right. So when you contact us, you're going to need to make sure you have a few things here. I'm going to zoom in so you can see this a little better. When you contact us, we're going to ask for these things in these bullet points right here every time. We're going to need to know, most importantly, we're going to need to know the serial number and what's wrong with the unit. Those are the two things that we need above all else. Of course, we're going to need to know who you are, where to send the unit back and all that. But without the serial number and a problem description, I can't even open a problem ticket. And that's what gets the whole thing started. But everything that we're eventually going to need from you is serial number of the unit, your name, your phone number, email, your billing address, your ship to address, and the issue with the unit. And now if you're contacting us on behalf of a customer that you have, that's fine. We may still need that end user's information though, because sometimes they have more insight to what the problem actually is. Now we're going to troubleshoot these things when we get them. We're going to figure out what the problem is. But in case it's something off that we wouldn't normally notice in an operation, that's why it's always great to hear from the end user if possible, but it's not always needed. If you have enough information for us to service the unit, we may just move right past it. But just know that we may ask you for end user information. Okay, so again, I'm going to go over that. If you contact us, we're going to need the serial number and the issue with the unit. Those are the two most important things. If you email us, just go ahead and put the serial number of the unit in the subject line. That way it's there. When I respond to people and I have a serial number, a lot of times I'll just add it because then I can find it again in my inbox. I don't know about you, but I've got tens of thousands of emails in my inbox. So if I have to go back and search through those, it's way easier just to search by a serial number. That being said, that's something I like to do. You don't have to do that, but you might notice that if you've conversed with me via email before. Anyway, we'll move on. Just remember that serial number, name, phone number, email, billing address, shipping address, issue with the unit. Okay. All right, now we do have a NextGen customer return package. This goes hand in hand on if you need to send it back to the repair depot. So we have a packaging kit. It's a big kit, comes with straps, comes with a pallet, big cardboard boxes with foam inserts. We've drop tested this setup and we know that it can protect the unit better than anything else that we've come up with. So if you need it, we can send it to you. Typically, it's an extra $200 to $250 charge on the service order for billable. So just keep that in mind too. So like I was saying, shipping carton and strap, there's a strapping tool. It's a cool little tool that comes with an instruction. It helps you to pull the straps and to cut them. Pallet strapping buckles. So to prepare your NextGen for shipment back to us, you kind of have to put it back to the way that it was shipped out. All right, and we're going to go over that. Now to prepare it, you'll have to replace the shipping screw, okay? And this shipping screw goes through the fraction collector arm, but there is a spot behind the front cover that you can put this just to kind of keep it out of your way if you ever need to use it again. And in fact, I wanted to show that to you real quick. So I'm going to stop sharing my screen here. All right. This is my handy dandy unit that we're going to use for demonstration purposes today. And so what I was trying to show on here is this is that shipping screw right here. And it's just a thumb screw. If you notice, I don't need a tool. But it just comes out just like so. Now, if this is in here and you try to turn on the unit, you're going to hear this kind of make a move like that, and you're going to get errors. So you want to make sure that you don't ever try to turn this on with your shipping screw installed. If I can tilt it down just a little. Front cover here says NextGen 300 plus, but it can actually come off. Just pinch it both sides. Well, it was supposed to come off all easy to show you how easy they come off, but of course, since people are watching me, something like that had to happen. But anyway, you pinch on the sides here, and it should pull right off. That's how easy it's supposed to come off. Now, on this side here, it's going to be to your right if the screen is facing towards you. But there's a spot down here. There's a small hole. And this thumb screw can just screw right into it. I'm going to leave it there for the remainder of the training because I don't want it to be in the way when we actually do a PM demonstration. And for those that don't know, PM stands for preventative maintenance. It's something that we recommend be done on a unit yearly, and it's vastly important to the lifespan of the unit. I don't have an anecdotal lifespan report or anything on this yet. There's still 2 new units, but I've heard some engineers say that a yearly PM will extend the life of these things at least 5 to 7 years. So whatever the lifespan is, it can last 5 to 7 years more if you keep a PM on it every year. But that's the shipping screw. So if you want to ship it back to us, obviously, you would just take that front cover off again, take your thumb screw out, and put it back into the fraction arm. Simple as that. Move this back. Get back to the manual. There will be a time for questions later. We will take a short break here. I don't know what time it is for you. It's about 7:20 for me. So I'm thinking in maybe 2 hours, I'll let you have a short break, digest any information I'm giving you. And we'll move on though. We'll cross that bridge when we get to it. All right, let me share my screen here again. Okay. So that was the shipping screw. Next, you're going to need to coil the tubing into the back of the unit with the clamps you removed when the unit arrived. So I'll show that to you real quick. What we're talking about is right back here. So if you do an install for a customer or for yourself, don't get rid of these black loops here that hold the coils in. What we always suggest to people is to, obviously you need to remove them to take the inlet lines out, but then we ask that you put them back. Just screw them back into place, okay? So I'm going to take those out real quick so you can see what I'm talking about. Number 2 Phillips head screwdriver. I'll go over what tools you'll need, what tools I take. But for starters, I'm just going to use a number 2. Let's get the second one out here. These clips just slip right out. They're plastic, so they can break, but if you're kind of gentle with them, you'll be fine. So I've taken both of these out. So what you'll probably be used to seeing is something like what it is right now. You've got your inlet lines in your solvents. You need to pack it up, send back to us. We ask that you put the clips back, so you'd have to take them out again. Just coil everything up. Slip the clips just around the inlet line and screw them back in. Simple as that. You know, we're not too complicated here today. I want to show you things practical. This is something that you'll probably have to do. So again, if you pretend you're doing an install now, you got your inlet lines, you're ready to put those in solvent and everything. Before you move on, we just ask that you put these clips back, okay? So that's what I'm going to do real quick. Fun stuff. Resemble this, what you see here. This other tubing right here and this apparatus up here is something you may or may not have in a unit. It's called an ELSD, evaporative light scattering detector. It is an option no matter what kind of next gen you're talking about, 300, 300 plus, 100. They are optional. So this may be a blank plate up here, or you may be having a tubing line like this, or there's another thing that screws on here that has a tubing line that comes down with a metal piece that comes up. So don't be thrown off if one day you see one of these here. It's just an extra detector that can detect things above and beyond what the detector in here can actually detect for UV or UV vis. Okay. But that's these clips that we were talking about. So we'll move on. All Okay, now in the shipping container that gets sent to you, should you need one, or if you keep a container that gets shipped out to you, you're gonna notice these foam inserts. And in these foam inserts, they're shaped. One's for the top, one's for the bottom. Over here on the left side, this one's for the bottom. This one fits around the top. And they're shaped so that they can fit in one way. Now you can force it any way you want, but this is shaped so it goes a specific way to protect it in shipment. So if you're sending it from overseas somewhere, it's got a long ways to travel. So it's a really good idea to do these right. So just take your time. It's not a race or anything. Yeah, you don't have to hurry to get it in the packaging because you want to do it right, because shipping damage is never fun for anyone. Okay, moving on. Once you get that secure in those foam inserts in the top and bottom piece, so this is the bottom piece, top piece, then you're going to need to strap it like so. And this tool here, it's a crazy looking tool, but it comes with instructions that make sense pretty quickly. And these are the strapping buckles. This is what you loop the straps through, and you pull the straps with this guy, and these buckles tighten down. And that's what the tension is on the straps. And here you have a pallet underneath, and this is how it ships to us. Okay. You'll get, if you need to ship back to us, you'll get what's called an RMA, Return Merchandise Authorization. All the more reason why when you contact us, you give us all the information we need so that we can generate that RMA. And you may have something else to put on the outside of the box that we ask you to send. It's not always every case, but sometimes we need like a decontamination form or something like that. But we'll cross that bridge when we get to it. We will let you know what we need. Otherwise, just shipping label and a copy of the RMA on the outside of the box would be great. All right. Preventative maintenance. This is something I've talked about a couple times already in this training. But the next table I'm going to show you is just showing some of the scheduled maintenance tasks. Some of them are in the PM kit and some of them are not. And it's going to tell you the frequency in which you should be doing these things. Okay. So we're going to go through that real quick. So the part number for a PM kit for a NextGen 300 or 300 plus is 605-257-009. The PM kit for a NextGen 100 is the same part number ending in 10 instead of 09. And in that kit, you're going to get new pump seals, a new lamp. You're going to get a universal verification kit, which is test mix. It's a standard. We know what kind of peaks and the generalized time in which those peaks are supposed to come off. We know the generalized shape of what those peaks are supposed to be. So this is a great test that we ask people to do a lot of times because it shows if your unit is performing right or not. It shows if your flow cell is functional. It shows if your flow rate is correct. If your flow rate's off, then your gradient's not going to form correctly and your peaks will never come off correctly. So the universal test mix is a great troubleshooting tool. All right. Now, some of the things that you're going to find here, again, pump seals. And we do recommend that you do that annually or whenever your unit is telling you that the pump strokes are exceeded. That is resettable in the service menu. I'll show you that later. But there's a counter inside there that's counting. Some units it's 100,000, some units it's 200,000 strokes. But as you approach that number, the unit's going to start to give you warnings that you're getting close to the lifespan of your seals. If you go over that count, it's going to tell you to contact someone to replace those seals. Next, you're going to get a couple O-rings. These O-rings go in between the check valve housings and the pump head cylinders. And believe me, I'll show you everything like that later. But I have a pump here that I'm going to go over with you. But the There's O-rings in there. These just make a tight seal between the cylinder head and the check valve housing. Okay. Speaking of the pump cylinder, anytime you replace the seals, we do recommend kind of a slight flush of that cylinder. If you've got solids in there, you got scratches, gouges, or anything like that, you want to see those. You want to clear them out if you can. So when you replace the seals, you can ruin a seal right away by having stuff in your cylinder. So if you have a squeeze bottle with some IPA or some methanol or something, just go ahead and squeeze it out into that cylinder, get it nice and flushed out. All right. Next, we're going to be talking about the lamp. The lamp is the device that shines light through the flow cell, and that is going to give your absorbance. The absorbance is what the unit is actually doing. So the peaks that you're seeing is just an absorbance at that wavelength of some kind of sample, compound, whatever it is that you want to detect. The lamp needs replaced pretty often. I've seen lamps last as long as 7 years. I've seen lamps last as long as 7 months. Now, the average lifespan of a lamp is probably going to be somewhere around 2 years. And that's with daily on and off of the unit. We do recommend that you replace the lamp annually, though, as we do recommend a PM kit annually. But it's up to you what you want to do. But we really recommend a yearly replacement of seals and lamp. All right. Now, the lamp fan is a fan that's on the back of the NextGen, and that is spinning onto the lamp itself. The reason for that is because the kind of lamp that we use, it will overheat and it will destroy itself unless there's some kind of cooling done. As a kind of redundancy on that, we have a thermal breaker that's attached to that lamp, and I'll show that to you later when we're doing the PM. But if the lamp gets too hot, that thermal breaker opens and the lamp will not conduct. You'll get an error on your screen saying lamp failure, something like that. More than likely lamp failure. And one of the things you need to check is that thermal sensor. And I'll show you how to do that in just a little bit. All right, so if you've got solid sample cartridges, and these are metal devices that go onto the cartridges. Cartridges are typically used for solid sample, even though I have seen some used for liquid, but there are seals on these solid load cartridge caps. And one thing you'll start to notice is when you use a cartridge with a sample in it and you move the plunger down, you're going to see liquid level going above where that seal is. And it's a big white Teflon seal. You can't miss it. Now, if that liquid's going above and beyond where that seal is, it's time to replace it. And the good news is that's much cheaper than replacing your whole cartridge cap. So we've got part numbers here on this table for you. And if you need to, just email me. My email is judd.smith@teledyne.com. I respond to isco.service@teledyne.com emails as well. So it's up to you, however you want to contact me. All right, the drop former. Drop former is a part on the diverter valve, and the diverter valve is in the fraction collector arm. So when we do a separation on these devices, if you want to collect that separation, you have test tubes in the fraction collector area. And the arm is just that thing that we took the screw off earlier. So there's a drop former, and this is a shaped part that makes it so that you get droplets into the test tubes. It's not spraying everywhere or anything like that. This drop former can clog. It can become broken. Many different things can happen to it. So it's a good idea to check it. We want to do an alignment on it. That's done in the service menu. And we would recommend that you do that every year, just so you're not going to lose any sample off to the side of the unit it's collecting into test tubes. Now the unit has basically a computer inside of it, and the brains of that computer is what's called the motherboard. The motherboard has a very small little coin battery on it, And we recommend replacing that every 5 years. That battery, what it's doing is it's storing clock information and some other random registers on the RAM. So when you remove that battery, the unit might think it's 1969 again. That's a way to know that you either got a default unit or the battery's been pulled or the battery's dead. It can't keep time. Now, if you're networking your unit to a larger network for file saving and stuff like that, it's going to be a big problem for you because you need that time to match what your server says the time is. So keep that in mind, but we do recommend you replace that battery every 5 years, okay? Flow cell. Flow cell is the component. There's 2 fiber optic rods inside of it that make a gap. Your solvent sample is moving through that gap and the light shines through there. That's how the machine works in a nutshell. So the flow cell needs to stay clean. These are quartz rods. They look like glass, okay? They need to stay clear. They need to be able to pass light through them. So we recommend flushings, all right? We recommend every now and then you take it out and inspect it. I'll show you how to do that today. This says monthly. I would almost flush your flow cell twice a month, depending on how much you use it. If it's a daily device for you, if you're using it anywhere from 4 to 8 hours a day, every day, flush it twice a month. I like to flush it with methanol because I have it so readily available. Acetone, though, is a great solvent to use. Flush it through your whole system. It'll get rid of any sample that may be hardening into like a crystalline. It can flush out any impurities that may be lingering in your system, and it will also flush out your flow cell. It'll clear out the gap. The rods, those quartz rods can start to stain. You might see them start to turn a yellow or a green. Acetone really helps with that. So there is a table here that we're going to go over that shows a lot of the suggested solvents. At least I hope it's in this manual. I know it's in mine that I wrote that will be on the website soon, but I hope it's in this one too, because it's a great table. Fraction collector tray is just a tray where the fraction collector racks go, where your test tubes are. I don't know if anyone actually cleans them, kind of from my personal experience, because it's always pretty nasty. But you know, if you can, just take a rag, clean it off with some IPA or methanol. It's up to you though, it's your property, but when we service them, we always appreciate it. Okay, moving on. Recommended spare parts. These are things that I would probably keep on hand if I were you. These are things that I keep on hand because I'm me, so that I'm ready to go if I have to service one of these. The tubing, there's a lot of black conductive tubing. And the reason it's conductive is because hexane can carry a static charge. So our tubing dissipates it. Some of the other solvents you may use do the same thing, but hexane is the big one. If we don't dissipate that, it can just continue to build up a static charge. Hexane is flammable. So just take care. Make sure you're using any of the fully conductive black tubing. Part number here, we sell it by the 120-inch amount. I don't know what that is in CM or anything, so I'm sorry that I didn't do a conversion for you. But moving on, we have nuts and ferrules that go on that tubing. We recommend having about 10 each. Next is the flow cell itself. We do recommend having a spare flow cell. There's nothing worse than knowing what you need, ordering it, but it's not to you yet, and you're down and you've got a project going. Keep a flow cell handy. Keep a flow cell handy if you're working on customers' units as well, all right? If not one, if you can swing it, I would maybe have 2 or 3 on hand, okay? Next are the motherboard kits. So we have 2 different kinds of NextGen 300 and 300 plus. Now, as far as I know, we're really only producing the 12-inch screen right now, but we did have a 15-inch screen, and I would not be shocked if people still want it. but it's a different motherboard if you have a 12-inch or a 15-inch. And the reason for that is because the screen itself has a firmware, and that firmware interacts with the motherboard. So you need to have a different set of software on that motherboard, different BIOS. So if you have a 12-inch unit, you need to have the 003 part number there. And if you have a 15-inch unit, then you want the 004. Motherboards on some of our past units were a hot item. It was one of the more common things that would fail if it did fail. So far, anecdotally, I haven't seen too many motherboard failures, but I have seen some. So if I were you, I would keep one, if not two, maybe even three, but two is fine, of the 12-inch motherboard sets. You can maybe keep a 15-inch on hand for that day that you finally service one. I would keep one of those on hand. But for the 12-inch motherboard, I would get two, if not three, and just store them. All right, but that's up to you. I'm just recommending things. I'm not telling you what to do. All right, next we have pump seals and the pump itself. You need 2 seals per unit because there's 1 seal per pump and there's 2 pumps per unit. So I would recommend having 2 pump seals per unit. Actually, I'd recommend maybe having 6 to 10 pump seals on hand, especially if you're servicing customers' units. More the merrier. You'd rather have too much than need them and not have them. So yeah, 6 to 10 pump seals would probably be a good on-hand backup for you. That's just me though, okay? Not telling you what to do, but it's a good idea. The pump itself, they're a little pricey. So I would maybe have 1 or 2 of those on hand if you're servicing a lot of units. Pump here, they don't break too much. There's certain things on them that can break. There's a bearing here. There's a belt that can snap. There's things like that that can break on them, and they're not sold individually. Okay. Check valve housing, the pump seals, those things are sold individually, the sensor too. But if you need a new ball screw or a new pulley on the bottom, you're looking at buying a new pump. So you can purchase those pumps and take parts off of them if you need to. But what we sell now currently is just kind of the pump as a whole. Contact me, contact Philip, contact who you need to contact for what's available, what the best solution is for you. I know there's some people in this training that already do that with me. That's great. Let's keep going with that. I'm more than happy to help you. But a lot of times you're looking at buying assemblies now. It's just kind of the way the world works. So we'll do what we can for you, but just keep that in mind, okay? It might be a good idea to keep 1, maybe 2 pumps on hand if you can swing it, okay? All right, we're gonna move on a little bit. So this is just a nice little checklist for you here. Something that you can fill out, you can date it, you can put your name and everything. It's basically everything I just talked about, and it's just your way of making sure that you did it. You can hang it up, you can laminate this and put it on the side of the unit if you want. It's up to you. But this is just kind of more of a reminder, a checklist, a thing for you to keep everything together, okay? All right, we're gonna start accessing the inner components. So this manual is just going to show you pictures. It's going to show you circles of places to remove screws. I think it's best that I just show you how to take the unit apart. So I'm going to remove this side panel that you're seeing here. Then I'm going to show you everything that's in the unit that's on this page. Okay, it's page 15 if you're following along in your manual at home. We're going to remove the top cover. And we're going to remove that dang USB port. All right. We're going to remove the ELSD in my unit here. I'll show you everything in the motherboard compartment quickly, and we'll remove the rear panel. I'm not going to remove the bottom panel. You probably won't have to do that too often, but when you do it, it can be frustrating. So contact me if you need to, or refer to the manual. So what I'm going to do is I'm going to stop screen sharing here. And I'm going to go ahead and start tearing this unit apart so you can see how it all comes apart. Now, to take this apart, there are some tools that I recommend that you have. Okay. Phillips number 2. Okay. Phillips number 2 screwdriver. That's the big one that I would suggest you have. You might also need a pair of side cutters if there's any zip ties that get in your way. An adjustable crescent wrench always comes in handy. A nut driver. Now, this technically is an 8mm nut driver. The one that we recommend you have is a 5/16 inch nut driver, but my 8mm one works just fine as well. I don't know if it's easier for you to find or what's harder for you to find, but 5/16 inch standard or an 8mm seems to work as well. All right. Without further ado, we'll take off the side panel here. Just so you can see it. It's just a series of screws, 1, 2, 3, 4, 5, 6, 7. Don't throw away these screws or anything, because when we're done inside the panel, you need to put them back. I usually have some cups or an ice tray or something like that to put them in, just because you don't want to lose them. All the screws around the unit are the same size and thread, so you don't have to worry about keeping the screws straight or anything. I do only use hand tools. I try not to use power tools just because I don't want to over torque anything, snap a screw. Sorry, I'm trying to do it so you can see what I'm doing. One more screw here. You can see it's already wanting to fall on you. So when you take your last screw off, depending on which one or what position it's in, you can grab this arm handle here with your free hand if you've got one. Just go ahead and take that last screw out. And since I've already got my hand here, it can come. Otherwise, it's just going to want to fall on you. See that? So be aware of that when you take that panel off. But here I've got it off. Set that to the side for now. But here you see the inside of the unit. I'm sorry if that's not very focused or anything. My camera's kind of stuck with the zoom that I'm on right now. That's a little better, I think. A little. But anyway, we're going to go over quickly what's in here, so we'll start at the bottom. Now this is a NextGen 300 Plus, as I was saying before. So here in the bottom, I've got my injection valve. All right, this moves up and down with the trolley. So when you install a column down here, you have to move the trolley up, and the injection valve will move with it. The injection valve just changes your flow path with a rotor. So you can go direct to waste, you can go through the column, but not the cartridge. You can go through the cartridge and the column. You can go direct to the flow cell, things like that, okay? So that's what the injection valve does. Here are the pumps, okay? So on the pumps right here is the cylinder that I was talking about. This is where the seal is. And here's the check valve housing. So the O-ring that you replace is in between here. And on this one, it's right here. Okay. Now over here, you're going to notice the solvent select valve or the solvent manifold. So you've got 4 inlet lines that can go into the NextGen. And this is what is toggling what's active to go into the pumps. All right. So if you're using 1 and 2 and you're setting up a gradient, this is toggling between 1 and 2, depending on what your percentage of B is on your gradient. So, you know, it's going to allow 70% of A in and then 30% of B in. This guy right here. Back behind here are the pressure transducers. This is what measures your overall system pressure. And that's what displays on your screen. Pump boards, we call them. But these are kind of like the control boards in our older unit, but I think they're way cooler. So you hook up the pumps, the sensors, transducers. If you have a vapor sensor down here, which this unit does not, it plugs into this board as well. A lot of stuff plugs into this board. 3-way valve for if you have ELSD, and it helps set up your path through the system. Okay, that all plugs in here. You can't see it, but behind here is the left-right motor for your fraction arm to move. Okay, that's this motor right here. Moving up just a little bit. I said it already, you can barely see it, but there's a 3-way valve right here. Now this is the optical assembly up here. This is that lamp that we've talked about. It'll need replaced. Here's the fan that blows onto it. Okay, you can't see that thermal sensor, but it's back here. I'll show it to you when we take this out. But this lamp shines a light through this, the flow cell, and you see these black lines. This carries the solvent and sample to the flow cell. So there's, like I was saying, there's a gap there with those quartz rods. The solvent comes through the gap. The light shines through the rods. So as the light shines through here, you got solvent coming up here. It absorbs at certain wavelengths. And this guy, the detector, is telling the unit it's absorbing at 254. Oh, we've got an absorbance at 280. Or whatever you have it set for. 254 and 280 are kind of the defaults that we look for, but there are all wavelengths that you can turn on where it's doing the entirety of the spectrum that it can handle. So we have a UV or we have a UV vis detector. The UV does 2 to 400, I believe, and the UV vis does 2 to 800. So it's a much wider range of spectrum for the detection there. Now up top, this is the lamp circuit board or the lamp driver board. This gives the voltage for the lamp to turn on. This receives a signal from the detector allowing the lamp to turn on. It powers the lamp fan, and there's a spot for the thermal sensor to plug in back here. Again, that thermal sensor is just physically attached to the lamp. All right, that's a quick rundown on what's inside there. Next, I'm going to take the top cover of this off. So we've already taken out 2 of the screws that hold the top on. So we just rotate it around. And there's no screws on the back that hold the top on. There are 2 on the right side. And if I refer to a side of the unit, what I mean is if the screen is facing towards your chest, this is the right side, right? So just to simplify it even more, I've got it pointing towards my chest. So this is the right side of the unit. This is the left side of the unit. So the left side, the left panel is what we've already taken off. Okay, so I'm going to take off these 2 screws. And again, all these screws are the same size and thread. So you don't have to worry about mixing them all up together or anything like that. So I've got those two screws out. So I should have all the screws out to remove the top cover, right? Wrong. Check this out. I got a USB cord here, okay? This USB is great, don't get me wrong, but it's gonna give you fits when you go to take off this top cover. So what I do is I set it like this. You kind of see I'm setting it like this, or I'll set it like this. Whatever it takes to get these two screws out. There's two screws on either side of that USB. Apologies if you can't see that if it's not in focus. Sorry, technical difficulties with the camera. Doing the best I can, sorry though. But I'm gonna take these screws out now. Okay. And that's just on either side of the USB. A little closer. 1, 2. Just take those out real quick. Now these screws are different than the other ones. So I'm just gonna set those aside. So I've got those screws out. Now, you're not done yet because this slips in. And so you kind of have to just kind of wiggle it. I like to pull it forward a little. So you can kind of just slip it out. And it will slip out. It will. And you can dangle this here if you want. We do kind of recommend putting some kind of plastic bag around it. And that's more for protection because it can swing into the screen here. It can rub against your chassis. It's also another grounding point, but I've yet to encounter an issue with that personally. But okay, I've got my top cover off. Ooh, it's getting fun now. So here we go. Now, if you have a unit that has an ELSD like this one, that ELSD's got to come out if you need to get at the motherboard, okay? This is going to be frustrating for you the first time you take out an ELSD. But that's okay. Let's get frustrated together. I'm going to show you how to do it. Let's see. Oh, I should show you this. Just because I don't want you to lose these screws or get them confused with some of the others. These are the screws I took out for that USB. I just lightly thread them back into their spot. So I've got my USB here. I'll turn this. This is what we just unmounted. I just kind of lightly thread it back onto here. Just a few turns. And again, the reason I'm doing this is because these are slightly different. I believe they're the same threading, but they're a much different size. So I try to keep them separate. You'd probably be fine if you did mix them up, but I like to keep things separate when they're separate. So putting them back where they're supposed to go, just give them a few turns so you don't lose them again. Simple as that. Okay, back to the ELSD. There's going to be some screws back here. You're also going to have a drain assembly that is not on here. You just unscrew that. You know, that's where your pliers come in handy. If this tubing is bugging you, you can remove it. It's not bugging me, but it's just it's a slipped on barb tubing. So you can just turn it, just remove it. All right, so I've got 1, 2, 3 screws I need to take out to remove this ELSD. If you're going to do a preventative maintenance on the ELSD, I would heavily advise taking it out. 1 screw. 2 screws. And the 3rd screw is out. So you should be able to, oh, I can't move it yet. I wonder why. Wow, let's take a look. What is going on? Why I can't just slip it out is because I need to loosen some nuts in there. Okay, so I'm gonna take my 5/16 wrench. Remember, I was telling you to get a 5/16 nut driver. But I can't get a nut driver into these screw holes, okay? So I'm going to just loosen those up. And again, you just have to loosen these. You don't have to remove these nuts. Sometimes it'll cooperate and sometimes it won't. Sorry if you can't see what I'm doing, but what I'm doing is there's 4 nuts that mount it to the chassis. They're shown in the manual, and the nuts are circled, okay? So just locate them and loosen them. That's all I'm doing right now. One more to go. Should be good, right? Some wiggle here. So what I'm doing. So this is the ELSD again. And look how I've got wiggle now. So I can pull this out, but I still have a couple things to think about here. There's tubings that come. And what I did was just cut away the zip tie that holds those tubings in, okay? And one tubing line comes right down here to this 3-way valve. So I'm gonna, comes right down here to this 3-way valve right here. So I'm gonna remove that. I try to do everything by hand, all right? These mounting nuts are called PEEK material, P-E-E-K. They can break if you use tools on them. If you need to use a tool on them, you can only use a tool to loosen. You can give it a pinch and loosen real quick, but try not to use tools to tighten them back down if you can help it. You do you, but I would advise not doing it because eventually you're going to snap one. Now my other tubing line is this one here. It's got a sticker on it that says FC for flow cell. All right. This is the other tubing line I need to take out. So let's see if I can. Oh. So I'm going to show you what I'm talking about. That one's on there pretty tight. It's hard for me to get a good grip on there with my fingers to remove it. So I'm just going to give it a little pinch. Boom. There, it's loosened. Now I can take it off by hand. So we'll do that real quick. Now, I should be able to lift up. That was something. Oh, piece of my fan, oh no. Anyway, there's some electrical here to keep in mind. So what I do is I set it up here on the corner when I have an ELSD, and I start looking at what needs connected. There's a connector that goes to the top of the, the connector here that goes to the top of the pump. Again, this is all in the manual. So if you can't see exactly what I'm doing, I'm just doing a quick representative training today. So if you were to get the full training, I would go into greater detail of what I'm doing right now. But right now I'm doing electrical removal. So I'm just finding the electrical lines that are coming out of here and I'm disconnecting them. So I've got this communication line that I need to remove. I've got this blue and brown line. This is actually AC, alternating current voltage, 120 or 240, depending on where you are. So that needs to be removed. And lastly, I've got my DC power that's routed up. So that will need removed. So now the ELSD can come free. I'm going to set that aside probably for the remainder of the training. I'm in a room that's closed. There's no fume hood or anything, so I'm not going to run solvents through the thing today. So I'm not going to be too worried about putting the ELSD back. You do have to run the thing with solvents when you do a PM, okay? But we're going to pretend that I'm running solvents when we get to that point, okay? All right. So we've got the side cover off, we've got the top panel off, we removed an ELSD, even though you could barely see what I was doing when I removed the ELSD, we did it. All right, next, back panels. There's two panels back here, actually. We're gonna remove both of them. So it's just a series of number 2 screws still. There's 1, 2, 3, 4. Now above this back panel is this cover plate for the motherboard. That can come off as well. So if you need to replace the motherboard, just take this panel off like so. Set that aside, there's your motherboard. I'm going to keep removing screws here. Something you may have noticed is this big white switch. That's actually a circuit breaker. We're moving away from fuses that break and need replaced. So instead, we have a circuit breaker. It's a rocker switch. I would just turn it on and leave it in the on position. I can't tell you how many times we've taken the phone call. My unit won't turn on. Have you checked the breaker in the back? There's a breaker in the back, and they flip it up and it turns on. Happens all the time. So if it's off, just turn it on, leave it on. If it turns itself off, then we've got to identify the issue, if there is one. But anyway, I'm going to keep removing this rear panel. Just keep taking out these screws. Fun stuff. Now I've got the back panel off. All right. So what you see back here, power supply. Okay. Now this is unplugged so I can touch things. Don't worry. Power supply, high voltage. This is the dangerous part. Okay. So if you're back here doing things, wear gloves, observe ESD protocols. Just be careful because this is the line that can bite you. All right. Power supply, this puts out 36 volts, and there's a secondary voltage up here. there's a fan that spins on this, okay? What else you're gonna see back here? I told you about the left-right motor that's actually here. Can't see it very well. But what else is back here is the front-back motor. So we were talking earlier about the drop former that drops your separations into test tubes. You've got a motor that can move the fraction arm left and right, and that's right over here. But this motor moves that drop former front and back. So that's your X and Y axis, okay? This guy and this guy. Those motors move the front and the back. Okay, it's left, right, front, back. And you're gonna notice a lot of tubings here. Now this screw hole right here that mounts the back panel, there is a potential it'll catch on this tubing, okay? If that's the case, you can remove this screw. But since that holds one of those loops, the only thing I personally would ask is you move that loop to like this screw. Don't use either of these three. Don't use those three, but use this screw, or you can mount it on one of these screws. Just don't lose that clip, okay? But if you're noticing that you're getting hung up a little bit on this tubing from this screw, it's okay to remove it. Now the other panel down here, this is for your air supply if you have one. So it's the same 4 screws. So how it works is we have an air pump down here. This pumps a small amount of air into your clear lines for your inlet lines. That's going to generate bubbles. And the machine takes a reading of how much air pressure is needed to generate those bubbles. And through a mathematical equation, tells the unit, then you have this much volume in that container in centimeters. And that's a reading that you can see on the unit itself. We're going to take this out so you can see what's going on in here. Everything is in the manual that's in this assembly, but you've got your air pump over here. You've got a muffler. Oh boy, that is really washed out. I'm sorry if you can't see that very well. I'm trying to. Here's a better example of one that's already taken out. So you've got your air pump. This is what generates the air pressure. You've got an air solenoid. So this just turns on or off to allow air through it, okay? And different paths. You've got a reservoir that just holds a small amount of air that's usable for the pump. And you've got a muffler. This just quiets down everything, all right? This is the main circuit board here, and there are pressure transducers that are sensing how much air pressure is needed to make bubbles in the solvents, as we kind of talked about. That's the air system in a nutshell. There's a cord that plugs in here that goes up to one of those pump boards that we talked about in the left side panel. That's the air system. Won't always be there. It's an option on the 300. Actually, no, I don't think it is anymore. I think it's standard. I'd have to check on that. But that's the air system in a nutshell. Okay. So far we've taken the unit apart pretty well. I'm going to leave it apart probably for the remainder of the training, so that if we need to, we can take something apart. If you didn't get a chance to see something very well, it's going to be taken apart so I can point at things. But I am going to move on a little bit. Collect all my screws so I don't lose any. Oh, I see we have a question here. Take a look. No, we don't recommend you needing to do anything with the air pump in the PM, except making sure it works, essentially. There's a button you can push in the service menu, and I believe manual control too. To turn on the air pump, you can hear it operate, you'll be able to see the bubbles, but there isn't really anything in the PM to help service or maintain the air pump or the air system. I guess just make sure it works. That's the best I can do. Okay. This all set aside, we'll move on. All right. So this part of the manual is just showing you how to take that bottom panel off. And again, I'm not going to do it in this training. It takes a while, and I want to make sure to get everything that we need to get to done. We're moving right along, so that's the good news. Let's see here, but this picture shows where the screws are. You have to tip the units on its side. We recommend tipping it on the side that the pumps are on. So that'd be the left-hand side. But it's pretty straightforward. And if you take it off, what you're going to see here is the bottom of the pumps. Here they tipped it over on the right side. And that's fine. That's just, I usually advise people do it on this side. But here's the bottom of the pumps. So you can see the belts and the pulleys. These are the RFID readers. That's radio frequency identification. So our test tube racks have little tabs on the bottom of them that tell the unit what size they are. You can select manually, but with the RFID, you just insert it and the machine reads it and knows what you've got there. Now, if it stopped reading racks, you might have to replace one of these. I imagine some people in this training have done that before, and it's not the funnest thing to do, but it's always easier if you tip it on its side like this. Oh, and here you can see that shipping screw for the fraction arm that's inserted on this unit. This is a drain tube. So if you do leak in your fraction collector area, it leaks out of this clear tube, and it's usually routed right through there to the back of the unit. All right, now if you contact us, we may ask you for your firmware revision. And on the main screen, it's there's going to be an option called Help. And under Help, there's going to be another option called About Peak Track. Now, if you click that, you're going to get this cool little screen here. It's going to tell you your networking information, including MAC address. It's going to tell you your CombiFlash NextGen version. This is your firmware version. Okay, our most current one is 0.86 right now. That can change. And sometimes they change without notification. And when I say without notification, I mean sometimes I don't even know. So every now and then I check to make sure on our website if there's not another available download. But on here too, it's going to tell you your operating system version. I may ask you for that if you contact me. Probably not, but sometimes I will. It's going to give you your pump version, detector version, inject valve version, level sense version. If we need to do some advanced troubleshooting on some kind of strange activity that your device is doing, we may ask you for some of this more in-depth version numbers, like your pump version and things like that. And that's all found here on About Peak Track under the Help menu, okay? Fluid path. We're gonna start talking about the fluid path of this unit. It's pretty important. There's a couple diagrams in here, not to toot my own horn or anything, but I think I made some better ones than the one that's about to release to our website. But these work just fine, Okay, so we're going to go over some of the fluid paths of the unit. If you are troubleshooting a unit that has high pressure or bad chromatography, maybe you've got a leak somewhere and you can't figure out why, this section of the manual is going to help you out tremendously. Okay, and again, you might be working on a unit when I'm at home asleep just because of time difference. So feel free, always contact me. But if you're not getting an immediate response, rely on the manual, okay? This is going to show you what you need to know. So when a run ends, it's going to do a post-run wash. And so here, these are the pumps. Or I'm sorry, this is the solvent manifold. And this is determining what it's allowing into the pumps, which you see here. There's the two pumps and their check valve housings. Let me zoom in a little. From the check valve housings, you go through the pressure transducer manifold. And since we're on a 300 plus or a 300 with injection valve, it's showing you the injection valve here. Okay, so it's going through, and since this is a post-run wash, it's going through the injection valve, through that three-way valve, and then it's going right through the flow cell, through the diverter valve to waste. So it's cleaning off all this line. It's cleaning off the flow cell. It's cleaning out the diverter valve. I shouldn't say cleaning. That's a bad word to use, bad terminology. It's flushing it, okay? So that you don't have any remnants of possible sample. It's kind of pushing through any solvent that may be lingering as well. Moving on. So this one's sideways, but this is the NextGen 300 plus and 300 with injection valve plumbing diagram. This is the overall diagram. Oh, that looks terrible. A little. So you got diverter valve, flow cell, spot to mount your column. This bulkhead here is a spot on the unit where there's a tubing line. So if you have a solid load cartridge, it would basically go right here at the top of the column block. Two external detector. What that means is that ELSD that we took out earlier. This is a spot where it can attach to. This union isn't always in our units though. As you saw with mine, it connected right up to that three-way valve. The other side went right to that flow cell. So I don't want you hunting for a union that may or may not be there, okay? Well, I'm sorry, yep, that may or may not be there. Moving on, you've got injection valve. We already looked at that. We already looked at the pressure transducers, and this is the manifold. You've got pumps with check valves, and you got a solvent manifold. Over here is the diverter valve waste. This is a bulkhead, meaning just it's a tubing line that goes to your chassis and it stops. So you can connect things up on the other side. But that's the overall fluid diagram. It's not the easiest to read when it's sideways like that, so my apologies. In the one that I wrote, they are all turned so that you can read it correctly. So can't wait till that drops. But I digress. So if you don't have an injection valve, what you're going to have is a smaller three-way valve. This is changing the system pressure too. So instead of 300 PSI max that you can run on this unit, because we have this other valve in place of the injection valve, now your maximum is 160 PSI. So keep that in mind. Other than that, there's no real difference in the fluid diagram. So these fluid diagrams are going to be available for you. I can drone on and on and on about them, but if you're anything like me, you need to sit, you need to study them yourself, and you need to get your hands in a unit. That's the kind of thing that we give in a full service training too. But here, just know you've got resources. The manual is going to have all this information in it, okay? Tubings and fittings. So if you notice what's going on here is it's showing you that these lines have different dashes or solidness, and there's part numbers that are given here. It's a legend, it's a key to let you know what tubings are where. These tubings aren't always orderable by themselves. So if you need to, go ahead and get a hold of me and see what tubings are available, okay?
Ой, у меня где-то это было, это дурацкая фигня.
Does someone have a question?
Я, видишь, пока с документами отвлеклась, говорю, вообще не поняла, что происходит, какие-то тут электрические схемы начались, и все, вообще ничего не поняла.
Jacques, I got your question here
Ну,
about
главное, чтобы я понял, мне
ELSD.
даже если я восстановлю, я электрические схемы друг от друга вообще очень далеки.
And
Как храмов, ты внутренности проводов разложит, я говорю, что случилось? Он говорит, ну погляди, тут все просто.
can I ask everyone to mute if you're not asking a question? Perfect. There is an ELSD section. It's going to be an addendum. It's being written by another engineer. I believe it's done. So it should be included in the new one that I'm going to add. So I hope that answers your question.
Лысенький мужчина.
Thanks, Judd. Just I haven't serviced one, so I haven't seen
Блин,
anything.
понимаешь,
So
вот это нет,
it's
no
вообще
problem.
нет.
No
Я еще
problem at all.
начало пропустила, вот я перестала вообще.
Can I ask everyone to please mute their microphone if you're not asking a question? ELSDs can be a little much the first time you service one, but after you do 2 or 3, you'll be fine. And I'm always here for you, so.
Вот что.
All right, moving on. So these are some of the nuts and ferrules that you're going to see in there and their part numbers. Some of them may look familiar to you if you've been servicing units for a while or working on them. No real crazy mysteries going on here. Just look through the manual and you're going to see everything that I'm looking at here. It's telling you what kind of ferrule goes to what kind of peak nut, goes to what kind of tubing, okay? It's showing you how to swage them, meaning it's showing you how to just put them on so they don't fall off. This cool little tool here, I have one of these. If you have one too, that's great. Keep using it. There's no problem at all. But you can swage if you're gentle in a port on the unit, wherever that tubing and nut and ferrule need to connect to, you can use that to swage. But what I would suggest if you do it that way is to tighten it in about halfway, ease it off. Tighten it in about 3/4, ease it off, and keep just going in. You should do it about 4 times before you get a full tightening. That way you're not gonna put too much stress on the threads of the nut or on the female side, okay? So just take your time on these things. You don't want to rush through something, break something, and then you're down for days. So just keep that in mind. All right, let's see what else we got here. We talked about that. We talked about all this. So something else I want to show you in this manual is we start talking about individual assemblies, individual components, individual parts. And each time that there's an individual assembly, component, or part in the manual, it's going to give you a name, all right? A name of what you're looking at. It's going to give you a part number of what you're looking at. Hopefully, it gives you a picture. I know on mine, it gives you a picture for practically every single one. I think some of these might be missing. It's going to give you a function, meaning this is what this part does, okay? Something else, it's going to give you failure symptoms. It's going to give you calibration steps. suggested tools to use to service said component, assembly, or part. And a service check, meaning this is what you do to make sure it's working. Okay. Now the failure symptoms section might be called service or failure symptoms. Just be aware. But each individual thing that we outline in this manual are going to have these sections. And it really simplifies things. And we've gotten a lot of positive feedback on this over the years. So we don't plan on changing this. If it's not broke, don't fix it kind of deal. So let's see. I wanted to make sure we touched on the flow cell. Oops. Whoa, that's really small. Perfect. So I'll give you a couple more examples here. So the solvent manifold, as you can see, it's calling it solvent manifold. It's giving you a part number. It's showing you a picture of what it looks like. And it's good for vice versa too. Like you're looking at something in the unit, you're not sure what it is. Well, you at least know what it looks like. So you can skim through the manual until you find the picture of the thing that's broken that you don't know what it is. And it'll tell you what it is, the part number, the function of it, how it can break, how it can calibrate if you can calibrate it. It's going to tell you this, the tools and the service check. And here I'll keep going through this example of the solvent inlet because it's going to give you a pretty good little servicing section. And it shows you where to screw in the mounting screws, the tools section up here in the service check. It's showing you how to remove it, or it's telling you, I should say. It's telling you how to remove it, what you should be looking for, where to use the certain tool, how many times to loosen the nuts. We try to get as in-depth as we can. Now, the service manual is designed for people that know what they're doing, so to speak. But I kind of write for a person who knows what they're doing, but maybe, just maybe, they're encountering something they haven't before. So that's the approach I try to take when I write these service manuals. Again, I didn't write this one, but I did write the revision that should be on the website extremely soon, okay? Let's see, I wanted to make sure that we discussed the flow cell. Okay, let's go. So if you look it up, if you're looking at our manual in PDF in Adobe, you can have this search function. So there I am. I just did the search function for the flow cell and there it showed it to me. We need to talk about the flow cell. I find it's very important. So a flow cell for a NextGen is typically going to have a gap of 0.1 millimeters. Remember I was showing you, not with my fingers. The part number for it is 605-234-018. All right. Don't think that you can just improve things in your unit by ordering a wider gap flow cell, and that it may, but we will ask that you keep the standard flow cell in your unit because a lot of other things depend on that as well. Our universal test mix, for example, depends on it being the normal 0.1 millimeter flow gap, okay? So here it's talking about that, and it's talking about some of the options you have to purchase. If you change out your flow cell for a larger gap, write that down somewhere, keep that in mind, because if we do troubleshooting with you remotely and we don't know that you have a larger gap, we're just going to keep troubleshooting and we're never going to figure it out. Okay, so we need to know if you have a larger gap in your flow cell. Now, I would guess that 98% of the NextGens in the wild have the standard flow cell inside them. So keep that in mind too if you're servicing them. Function, we talked about this a little bit already, but it allows the UV light to pass through and absorbance to occur. Sensitivity, larger path lengths are more sensitive. The greater the path length, the higher the absorbance of a given sample or solvent. All right. So now I'm not a chemist. I am an engineer. All right. So there is chemistry questions that you may have for me that I would have to yield onto our application chemists. All right. I don't always understand the chemical things, but I am learning, and I'm learning fast. I've got a lot of really fun books on chromatography I've been reading lately. Something you need to be aware of, though, and that's something called noise. So on your chromatography, you might notice it looks like a lie detector test, like grass. It's just spiky. That's noise, and that can be caused by air bubbles. It can be caused by pressure dips. It can be caused by a few different things. But if you've got air bubbles trapped in your flow cell, it can get caught in the gap, and you may have no detection, but good light.
Andando.
Yeah, question?
Va bene, tua mamma?
Okay, I'll move on. Your air bubble can also cause this noise, that rippling effect that could be from a pressure dip as well, but air bubbles can cause that too.
Vabbè, dai.
All right, now something you may see is this warning message right here. I'll zoom in a little. Flow cell cleaning is recommended. What this is telling you is that it's not detecting the light level
Va
that
bene, dai.
it should be.
Ottimo così.
Folks, I'm just going to ask you to mute your microphone unless you have a question, okay? Now, when this message come up, you want to do a flush. That's the first thing you want to do with the flow cell, okay? Flush it. Like I said, I like to use methanol or acetone. Please never, ever sonicate a flow cell. Do not put it in a sonication bath, all right? The reason for that is those quartz rods in there, they can shatter. We don't want that to happen to you, okay? Noisy baseline, low light level, no detection, higher than normal absorbances. You know, these things happen, all right? Now I'm gonna stop my share screen here in a second, and I'm gonna show you an actual flow cell. I'm gonna show you how to remove a flow cell, and then we'll move on. Calibration, it's all here in the manual for you. How to do all of this stuff, it's all here in the manual. And we're gonna do a light level check here. And what it's telling you to do is go into the detector screen of the service menu, set the integration time to 40 milliseconds, and the wavelength to 254, and record the light level. Remove the flow cell from the optical bench. That just means take the flow cell out of the unit. And the light level should not change drastically. A rise in the light level indicates a dirty or faulty flow cell. So what this is telling you, and this is something that I talk people through on the phone all the time, is you want to shine the light through the flow cell. Tell me what you're reading at 254, okay? Let's just say to throw a number out there, it's 1200, telling you that the value is 1200. Now, if you take that flow cell out and you shine light directly on the detector, all of a sudden it's 35,000 or 3,500, sorry, then you know that your flow cell is prohibiting light from getting through. So it needs cleaned, it needs replaced maybe. Some kind of service needs to happen, because your flow cell should not be stopping all of that light from passing through, okay? Now what I'd like to do is these next couple parts here talk about how to take your flow cell out, how to check it. There you can see the gap in that picture. It's very small, it's 0.1 millimeter, but you should be able to see it with your eyes. All right, it's showing you how to press upon them with a Q-tip here or a wooden stick. And the reason for that is these rods are held in place with a glue. So if that glue has come apart or cracked or dried out, then these rods can move. and pushing on this very lightly on the side and checking the gap again lets you know if that glue is still good or not. All right, flow cell removal. This is showing you how to do it. We're gonna do it together. So I'm gonna stop my share screen here. We're gonna take this flow cell out, we'll inspect it, and then we'll take a short break. How does that sound? You guys can stop listening to me drone on and on and on. All right, here we go. So, flow cell, start of the show, right here. Now, there's this rod, there's a fiber optic rod that comes from the detector and it goes into the flow cell. So you can't just remove the screws that mount the flow cell and rip it out, because something's gonna break. This is close as I can. All right, so actually the first thing you wanna do is remove the tubing lines. We already removed the bottom one, so I'm gonna get this top one taken off. So here we go. Now, if you need to, you can put like a piece of tape on here to remember that this tube went to the top of the flow cell and leave the bottom one alone. I just kind of remember where things go, so I don't do that anymore. But if you're not inside here very much, it's a great pro tip that I would give you. Like a little piece of painter's tape or something up here, just to remember that the one with the tape was at the top. Don't be scared to take pictures either. You want to take pictures of everything before you start tearing it apart so that you can remember how it goes back together. That's something I still do from time to time. All right, that's in there pretty good. So like I was saying, you don't want to use any tools to tighten if you can avoid it, okay? But you can use a very light pinch here to loosen, and then this will come out. Might have to wiggle it a little bit, as sometimes that ferrule can get stuck on threads. You can just kind of leave that tubing wherever you need to, so long as it's out of the way. Now we need to move the detector, okay? So there's going to be a nut here and here that we need to remove, and this is the configuration 2 detector. You might have a configuration 1. The configuration 1 detector just has these boards off to the side underneath this cover, like right here. But this is a smaller housing, so it's much easier to deal with, in my opinion. But I'm going to take my nut driver here. There's this nut here. I'm just going to loosen it. Okay. Then I'm going to go to the nut right next to it. I'm just going to loosen it. I didn't remove either of those. I just loosened. Then you should be able to remove it unless something is stuck. More. It's really stuck on there. There it's going though. There it is. All right, so you can see it moved. Now I can take the detector out at this point if I needed to, but I don't really need to. But something I want you to be aware of is that spacer right there. It's important. You don't want to lose it either, okay? So when you do this, what I do usually is I put my fingers on it and I kind of just wiggle this so that I can take that spacer out and I set it aside for later. I don't want to lose that spacer. I'll explain why a little later. So I got that detector out of the way. I've got the tubings off the flow cell. All right, now it's time to take the flow cell out. Number 2 Phillips again. And these are some longer screws. Yeah, those are longer. So set those aside. We're going to install them again later. Okay. Second screw is out. Now your flow cell is free. So you can take it, you can inspect it. Kind of see that. Don't worry, I'm gonna shine a light through it. You're gonna be able to see all this better. But you inspect it just to kind of make sure that nothing looks out of place right away. Awesome. I'm gonna move the unit out of the way. So here we've got a flow cell that I kind of cut apart already, so you can kind of see that it's opened. The flow cell itself has a side with screws. This can come off, and another side with screws. Another side with screws, so you can take this part off. Now the reason you would take these off is to get at those rods in there, those fiber optic rods. They can pull out. And you can kind of see it a little better on this one that we cut up. So if I were to take that screw out and take that plate off, you can see down in there is a fiber optic rod. Grab my flashlight, maybe you'll see it a little better. Maybe not. Sorry, guys, technical difficulty with the camera. There, that looks a little better. So you can kind of start to see what's going on in there. So when you take out a flow cell, you're going to have a gap in there. So what I like to do, I like to shine a flashlight through. You really can't see through there. But you shine a flashlight through because you want to see any imperfections that are in there. Now, a lot of times you can just blow that out and you'll be able to see that gap in there. Now, if you need to, you just kind of hold it up to a light, kind of like this, that I'm doing. You can't see the light, but I'm holding it up to a light and this gap has closed on this one that I'm holding. And this is why I keep this one. It's an example of a bad flow cell. So what would happen if I installed this one back into the unit is I'd have perfect light level. The light would shine through, but you would never get any detection on this. And you'd be pulling your hair out if you have any. I don't. But you'd be pulling your hair out trying to figure out why you can't get detection. It's because you don't have a gap here. So when you take it out, you want to blow some air through it. Okay, that'll get rid of any solvent or air bubbles that are caught in there still. And then you can hold it up to a light and you can check to see if there's any kind of gap. And there is a small one on this now, which tells me that the glue is bad. It's moving on me. But if I want to, I can start taking it apart. Okay, I'm going to do so. Do so right here, okay? Stuff out of the way. So I've got this side with the plate here. I'm gonna take that off. Now, I don't care about this flow cell. This is my demo one. But if you're doing this, put on gloves. You don't want fingerprints on all this stuff, all right? So now I've got those screws out so I can take this plate off. And what you see here is that's actually a quartz rod that's mounted in. That should come right out. Ooh, super cool, super cool. So that's a quartz rod. You'll see it better. It's very small. So when you get these out, if you've got a flow cell that just won't clean with acetone, methanol, DMSO, whatever solvents you're using from the table to flush out the flow cell, you can take it apart. And what I do is I usually have a business card. I either have a business card or I have these PM labels. So what I'll do is I'll dip a little bit maybe in some cleaning solvent, and you can scratch just the tip there. Just gently and lightly, just ever so slightly scrape that tip off. That helps with the flow cell a lot. You can also come to the side and just do a little bit of scraping there. Now the sides aren't as important as the tip, but if you've got a lot of gunk on the sides, well, that just collects more gunk. It's like a magnet for more debris. So you want to make sure that you get it all nice and scraped off, cleaned off. You don't always have to do this. 9 times out of 10, a flush of the unit will clean these. But if you need to, just scrape, 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 and you're done. Now, putting these back, you want to be gentle, okay? Do not be in a rush to do this, but you'll find the hole down in there that the quartz rod goes in. There you go. Now, another reason why we say not to sonicate is because that's glue right there. And this glue can become gummy and malleable again in certain solvents that we recommend for flushing out in here. This glue is only on this side. So if you flush the flow cell out through the unit, this glue will never touch that solvent. But methanol and acetone will probably break this glue down. So this is another reason why we say don't sonicate the flow cell if you can help it. Now, I'm not going to lie to you. I've told people to sonicate in the past because I didn't know. I learned. But here we are now. And I'm telling you, don't ever sonicate a flow cell. You're going to crack a rod or you're going to loosen that glue and it's just going to ruin your flow cell. So you can put it all back just the way we took it apart. I'll save the time of the training and not do that. But I wanted to, we're really moving along well. I want to stop for a second. I wanted to address the room, see if there's any questions right now. Any questions so far on anything? All right, everybody, it's 9:20. I'll give you a minute or two to get acclimated. Give me a chance to take one more drink of coffee here. Any questions, though, that you thought of during lunch? If you want to call it lunch. Perfect. Okay, what I'm going to do is I'm going to put the flow cell back. It's only going to take a minute or two. I have that table up that I was telling you about with solvents to use. So we're just going to do those real quick. I'm going to show you the RPL. Danny, no, I will not be doing training on the ELSD today. That would be part of the full training, but today is more of a, I guess you call it the bullet points training, kind of a taste of what kind of trainings we offer. And what we want to do is kind of get an idea from everyone. Feel free to email me afterwards. What are you looking for in future trainings? Do you want trained on ELSD? Do you want further training on detectors? Do you want, what kind of trainings are you looking for? Do you want the full training? Things like that. So just keep that in mind as we go through the rest of the training today. We've got another hour, maybe hour and a half, but there's going to be plenty of time for questions at the end. I want to leave at least half an hour for questions. I'm going to do a PM demonstration without running the test mix, so that should take about 20-30 minutes. And any pro tips I come across in my brain, I'll let you know, okay? Sound good? Any other questions, though?
Yes. I have a question about if you are having the flow cell, before you start your maintenance, to have a look, you're telling me in the service screen you can see the signal at 40 milli. Can you show what will be a good signal of
Yeah.
the flow cell.
Yeah, I can do that. Just keep in mind too, that when you go into that menu, you're gonna have a bar. And the bar will tell you if you're in the good range or bad range.
Yes.
So your light energy also will depend on what solvent is in the flow cell at that time. So certain solvents kind of slow down your light energy. But if you have no solvent in the flow cell at all, or hexane or no solvent at all is kind of like the benchmark we're looking for. That gives you the most accurate reading of your light energy, okay? So things like methanol and a couple other solvents may actually lower your light energy. But if you're going into that menu and you look at your light bar, it should give you a range that's good and then a smaller range that's bad. And you will get warning messages on your screen too. But that's a very good question. And I will turn it on so you can see all that, okay? We'll get to that. That's a good question. And I have another question here from Paul asking, have you seen much in the way of fiber optic failure on the detectors? Yes, yes, we have. I wouldn't say a lot, but I have seen failures. And what I mean by that is, this is the fiber optic rod that I was telling you about here. Kind of see it there. Sometimes this will block your light. So there's a tip there and a tip there that you can kind of dip the tips into methanol and clean with a Kim wipe or some other kind of lint-free wipe. Now, a lot of times that will clear it up and you will get light energy through there again. And a good troubleshooting thing is when you have bad light energy, the first thing that I would suggest you do is just take a light energy reading with the full thing assembled. And then you want to start taking things out. So here, for example, we've taken the flow cell out. So I would move the detector back and I would do a light energy reading through just the rod to the detector. If I'm still not getting good light energy here, we remove this rod. It's just a knurled nut. You remove it by hand and you shine light directly onto the detector. Now, if this is shining directly on the detector, it should peg. It should be the highest possible detector reading you can get. If you're not getting that, then you've got a bad detector. If you've got pegged detection of light energy from just the light shining on it, but not with the fiber optic installed, then your fiber optic is bad, okay? Now, I think what Paul's specifically asking is about the rods inside the flow cell itself. Have we seen failure of those? The answer is yes. We see gaps close. We see gaps widen. We see things get stuck in there. Sometimes even you'll have a cracked quartz rod that's inside there. Now, when you have a cracked rod, you may still have good light energy. You may not. But one thing you'll definitely notice is your chromatogram will be crazy. And that's because it's doing a little bit of refraction when you have a crack in there, okay? So I hope that answers your question. If I wasn't specific enough, let me know. But the simple answer is yes. The fiber optics play a huge role in the light detection, and we have seen failures of them. So be aware when you service flow cells, okay? Any other questions? Perfect. Okay. All right, so I'm gonna put this flow cell back. We're just gonna do everything in the exact opposite order that we did before. Okay, so I'm gonna start by just putting a screw in one of those holes. Make sure my detector is kind of out of the way as far over as I can get it. So just it's out of the way. And this is just what I do, okay? I start by just putting the screwdriver in that hole, and the screw, and I just start threading that on. Okay. It's not tight. You can still move it. That's key, because if you tighten that one down right away, you might not be able to get this one where you want it. So here I'm going to put that through. Wiggle it till it's where it needs to be, start tightening it down. And because I've got both screws started now, I can go ahead and tighten this one down. And you do want to tighten this down before you try to move that fiber optic rod. All of this that I'm doing and explaining is in the manual, okay? So if anything I'm doing isn't quite making sense or you're getting real tired of how blurry the camera is, just remember everything I'm showing you today is in the manual, okay? Now, to find that spacer. Remember how I said don't lose the spacer? Okay, here's why. There's, and this is all in the manual, but there is what I call the sombrero washer here, and it's a large washer that's bent. And it goes in here, and this nut tightens onto it. Now, what that's doing is stopping this fiber optic rod here from hitting the quartz rod. But this nut and the sombrero washer work in tandem with this spacer. They work together with it. So if everything's lined up and correct, then this fiber optic rod will not be hitting the quartz rod inside the flow cell. So I've got that spacer on there. And so I'm going to start moving the detector back. That's pretty good right there. So get that chance to zoom. There you go. All right, so you can see I've got that spacer in there. I've got it fully inserted. I'm ready to tighten the nuts back down. So I take my nut driver. Again, this is a, so you can read that, an 8mm. Now, officially, these are 5/16 inch nuts. But again, if you already have an 8mm, that's what I've been using for years. Sorry if you can't see, but I'm just tightening these nuts down. There you go. Not moving anywhere, not moving anywhere. I just put my flow cell back. And so before I go on to the actual PM, I'm gonna share my screen real quick. So I want you to see something from the manual here. All right, now what we're looking at here are the suggested flow cell cleaning solvents. All right, when you look at this table, it's telling you what solvents we recommend and what they're good for. And again, the two that I touched on were methanol at the top there and acetone that's a couple down. These are the two ones that I personally use predominantly. But if you're doing, again, I'm not a chemist, so if you're doing some kind of special chemistry separation, take a look at this list, see if there's something that'll work a little better. If acetone or methanol isn't cutting it, feel free to move down the list, try something else here. We have mixtures when you look down here that are 30-30-30s or 50-25-25s. And they are just simple mixtures here. Some of them work a little better. So if you've got a deep stain or you've got a very specific stain that you know will come off with this 30-30-30 mix, feel free, okay? Now, one of the last things I wanted to show you in the manual is what's called the RPL, all right? This is the replacement parts list. Now you need, I'm kind of skimming through, you can kind of see there's a wealth of stuff in here. And I know I sound like a broken record, but there's an even better manual coming very soon. More parts, more descriptions, better pictures. But we're gonna keep going because at the end of the document, here we go. This is the RPL, okay? Replacement parts list. Before I get too involved though, I need you to know that these part numbers can change. These part numbers can go inactive for sale, okay? They become obsolete sometimes. We've had to change to something called RoHS for certain circuit boards. So when we have a RoHS circuit board, it may have a different part number than our traditional one. All right, so you need to check with either me or all of isco.service to see if a part number is still active for sale on this list before you start ordering things. But how these lists work, we'll take a look here, is there's a big exploded view of the unit here, okay? Now, there's circled numbers that point at things. I mean, pretty straightforward. But it's showing, you know, parts of the air supply, the pump, all this stuff. And so as you keep going down, you look at more stuff with numbers that point towards things. So you find the part that you need, it's number whatever, 78 something. And you keep going down until you get to the list. And this list right here will tell you what that circled number is, the product name and the part number. All right. So I said 78, right? So let's look for 78 on here. 78. There's the part number. It's the seal kit, 2-pack standard. Okay. Seals. That's all there is to it. So you look at the exploded view because you know the part general area in the unit with the part you're looking for. You see that number corresponds to this list. Simple as that. Now you have your part number, so you can look on our online store just to see if it's still active, but online store is for North America only. So if you need to order something and you're not in North America, you can contact customer service, your distributor. If you're not a distributor, you can contact your distributor or you can contact isco.service. We'll get you to the people that can take your order, okay? And we can vet your numbers too, so we can make sure your number is still active. Use us, we're at your disposal. We're here to support you, okay? All right, I think that's enough of the manual for now. So what I'd like to spend the rest of the time doing is a preventative maintenance demonstration. So I'm going to show you the tools that I use. I'm going to show you the actual preventative maintenance kit, and I'll go over how to do it, okay? For this part, I'm going to be pretty into what I'm doing. So if you have a question for just this section, just shout it out, okay? If you're not clear about what I'm doing or you can't see what I'm doing, just shout it out. All right, we'll move on. Some of the tools I use, you want to have, a standard Allen wrench set. This is the set that I like to use because I can't lose them. They're attached. But we're going to be using some of these for the actual PM. The check valve housings need to come off to replace that O-ring. Those are held on with Allen heads. You're going to need an adjustable crescent wrench, and it's got to be wide enough to go on the jam nut at the top of the pump here. It's got to be wide enough. Otherwise, you're wasting your time. Get a crescent wrench that's wide enough. You want a 5/16 wrench, and you want a 1/4 inch wrench. All right, so this one has both. I have a 5/16 and a 1/4. So basically, you're starting to see that we run off a lot of standard measurements for our nuts and bolts. You want a small flathead screwdriver, and you'll see why when I get to the pump seals, but I use this on the seals. This is a valuable tool for the seals. Side cutters, because there will be zip ties from time to time. So you want to have them. Phillips head screwdriver. 5/16 or 8mm nut driver. I like to have a flashlight and a marker. Now these aren't necessarily 100% needed, but they come in handy, okay? So I would suggest having them. Paul, yeah, that was an SSI part number. That's a good eye. We use a 9-digit part number nomenclature at ISCO, but Teledyne also has an entity called SSI that makes a lot of our pumps for us. and they have a different nomenclature for their numbering scheme. So that was a good catch. All right, now I'm going to show you the PM kit itself. So when you order it, it's going to come in a bag like this. This is the 605-257-009. Okay, so this is the PM kit for the 300 and 300 plus. Let's take a look inside. Door opener up. And here you've got a new lamp with instructions on how to change it out, okay? This is the new O-rings. Remember, these are the O-rings that go in between the check valve and the cylinder head. And they'll go right in there. Universal test mix, okay? I'm gonna touch on this a little bit, but I'm not gonna run it in the unit because I'm in a room where I can't safely run solvents, okay? But we're gonna go over this, don't worry. And of course, you're gonna get new pump seals. Now, this baggie is mostly just to hold the instructions because they come with instructions as well. I'll take those out so you get an idea of what they look like. See? Nice instructions. You're gonna have pretty pictures. You know, we try to simplify it as best we can for everyone, showing you screenshots of what you'll see, how to take everything apart, blah, blah, blah. But we're gonna go through it all. Don't you worry about that. So, okay, let's get started on a PM. Ooh, I'm so excited. All right, we're gonna start with the lamp here, okay? So the first thing I wanna do is get my old lamp out. This is the lamp right here, all right? So I'm gonna get my tools handy that I'll need. Oh, I forgot to tell you that you'll probably want a number 1 Phillips head. These screws that mount here are a number 1, and these screws that mount here are a number 2. So my apologies, I should have mentioned that in the tool section, but I do have a number 1 tip on this screwdriver. Now to take a lamp out, replace it, the first thing you want to do is unplug it. Power off your unit. I can't stress that enough, power off your unit. Turn it off. Turn it off, turn the breaker off if you want. I don't care. Just make sure it's off, there's no power going, okay? Now, here's the plug for the lamp itself. And it can just come unplugged from the circuit board above, all right? This is called a Molex style connector. It has a little lip on one side that grips onto the connector. I'll show you how to put it back when we put it back, okay? It's kind of critical that you're not off by a pin. A couple other things to remove. The thermal sensor back here, you can kind of start to see now, but it's got a wiring harness that if we trace it, comes right up to the circuit board for removal. Okay, so that just comes right out. So those two are unplugged. All right, these are the things that you have to unplug. Now you can't just remove the lamp from this housing. And the reason for that is because of this thermal breaker back here. It's on a clip. And that clip is around the lamp itself. So we have to remove this to be able to remove that clip, to be able to remove the lamp. Let's get started. Here we go. So I'm going to remove this bottom screw to start. I'm using my number 2 Phillips on this. Now there is Loctite on the thread of these screws, so it may come off a little rougher than how I just made it look. Sorry if you can't see, I'm trying to do it so that you can see that there, you can see that. Just taking off the next screw, no great mystery to what I'm doing. Now I'm going to take off this screw right here. The 085 is for I'm sorry, I got a question here. What's the difference between an 085 PM kit and an 009? And the difference in the two is the 085 is used for the older model flash chromatography units called the RF and the RF Plus. There are a couple different things in there. Now, if you are in a pinch, I suppose you could use an 085 on a NextGen, but we do recommend you do order the we recommend you order the 009 or the 010, depending on which unit you're working on. Now, if you've got a stock of like 80 of the 085s, I get it. I get what you're asking, but we do recommend that you try to order the correct PM kit when possible. Is that okay? Does that answer your question? The instructions will also be different depending on which PM kit you have. All right, moving on. So I've got the lamp housing out. You can kind of see how that clip goes on there. This clip will be frustrating to you the first few times you do it, okay? But I'm going to show you how I do it. Now I get my index and middle finger on these tabs here, and on the other side, same thing. Index and middle finger. I use my knuckles of my hand to kind of brace against that metal sheet, and then you just split and pull off, okay? Now, alternatively, the other way to do it is to spread these apart and go from the top down. I'm going to leave it up to you what's more comfortable for you. There's pros and cons to doing it either way. If you don't release the tension enough on these clips, no matter which way you do it, it could pull this sheath off like it did on mine. See that? Pulled that right off. You can use a little smidgen of glue to put it back on though. Paul Stevens says these new spring clips seem to be a lot harder than they used to be and destroy lamps. I couldn't agree more with Paul. So these clips are a little tighter than they used to be. And it will do the same thing to you that it did to me if you're not careful, okay? See how that's moving around now? I'll show you how to fix that when we get to that point, okay? Actually, you won't have to worry about it because we're replacing this lamp. So we'll be good there. Oh, there that goes. Careful. Now I need to take these screws off, okay? I've got my number 1 Phillips head. So I'm just going to start. I'm setting all these screws aside for reinstallation. You don't want to get rid of any. Something else you might notice is these screws sometimes come off a little rough. Patience is a virtue when it comes to this stuff. So I'm just going to work around and keep removing these screws. Bring up the chat again. Perfect. Moving right along, almost got it out. Last screw out. Now, the lamp is free. Typically, you'll have that sheath still on there, but I ripped mine off. So I'm going to set that all down. I'm going to take out my new lamp. Okay. And again, in this bag, you're going to get directions. It's telling you how to do everything that I'm showing you. But it's fantastic. These are some of the best directions that we have, in my opinion. Here's the box that the new lamp comes in. Okay. Just open it up. You're going to see the caution. There's gonna be a foam thing in the top, comes out, there's your new lamp. Now, one thing I do, this is just me, this is a pro tip, I'll take out my good lamp. I will put my old lamp back in here, okay? Now, if you've got like 6 PMs that you're doing in the same area, this is a good pro tip for you. I'll close that box back up with the old lamp in it. Then I mark the box with my screwdriver. The next. This tells me this is a used lamp. Do not install this in a unit now. You can put X's all you want on it. Just something to let you know this is a used lamp, okay? That's what I do. You do whatever's comfortable for you though. So now I'm gonna take my metal housing again, and if you notice, there's 2 screw holes on one side, 1 screw hole on this side. I'm gonna take my new lamp. Don't put that clip back on yet. I don't know about anyone who's done PMs in this training group already, but I know I put that clip on and then I get to this point and I'm like, dang it, now I need to take that clip back off. But here we're gonna put this in, and if you notice there's a hole in that sheath, that hole needs to line up with this hole. That's why we do it this way. There's only one way you can mount this thing, all right? You can't mount it the wrong way with the hole shining opposite. You can't do it. So we put it together like so. Okay. And I'll get one of these screws started. And I don't fully tighten any one screw down until I at least get them all started. So I'm gonna get the second one started. And get my last screw started here. Now I'm going to go ahead and tighten this one all the way down. And I'll use the star technique. Go to the other side, tighten that down. And I'll tighten down my final one. Now comes the nerve-wracking step. We need to get this clip put back on here, okay? So what I'm gonna do is the same thing I did before. I'm gonna brace it, and you can either go from top down, or you can spread it and go from the side, okay? Now, no matter which way you do it, I would suggest before you get it on there, just to take them and spread them a little with your finger, okay? Loosen that up a little bit. Just give yourself a little extra tension. If you need to use a tool to do this, go ahead, but these can snap off, so know your own strength. Don't use too much muscle. We're just trying to loosen them a little. All right, perfect. Now I'm gonna move this out of the way because I'm gonna need a little space to work. Set it down right here. Now the name of the game is we want the thermal sensor on the opposite side of this wall, okay? We don't want to block any of this light coming through that hole. So what I'm gonna do, set it just kind of like so. I'm gonna spread my clippies. And I'm gonna get it set on there, okay? So here we go. There we go. Got it on. And practice makes perfect on this, okay? So just be aware that this can be frustrating. This is the critical step right here. Because if you break that sheath off or you crack your bulb, you're done. Need a new lamp. If you do pop the sheath off, then you can apply a small amount of glue to put it back, but you just got to make sure that these holes line up. You want to be able to look down through this hole and see that eye of that lamp down in there. You can kind of see it. But you'll see it for sure when you look at one in person, if you haven't already. But everything's lined up, everything's good here. I'm ready to install this back in the unit. So I'm gonna bring this back. Got my screws ready to go. And so before I even plug anything back in, I'm gonna make sure this is mounted, okay? Again, the light shines through to the detector, so you know which way to put it back. But just like the offset holes for the lamp, we do the same thing for the mount. So there's only one way this mount will possibly go back. So what I like to do is I like to get a screw in a hole, and then I press my screwdriver against it to hold it there. That way, when I go to put it in, I'm already starting the screw. Boom. Look at that. See, now we're having fun. Now I'm going to get the other screw put in. Again, I like to go in a star pattern, just meaning you go, you know, star pattern. Here it's more of a triangle pattern. And I try not to tighten any one screw down until they're all at least started. Okay, they're all started, so I'm going to tighten down. All right, that's done. Now I need to worry about getting these connectors back, okay? Now, this is going to be tricky for you to see, but on the far side over here, there's going to be a 2-prong connector for your thermal sensor here. And this has little tabs on it, so there's only one way it can go back. That one's pretty straightforward. Boom, done. This one's a little tougher. There's no outlying tabs. There's just this lip that grips. So it is possible to be off by a pin on this. You don't want that. You want this connected correctly. So as you go to connect this, you want to kind of look at it from an angle over here, so that when you put it back, you can make sure that all of your pins are engaged. I got all my pins engaged there. So I'm going to push up. And when you're done, do not be scared. Just poke your head under. You see that, how that was all on there? Poke your head under and just make sure that you got it on correctly. If you're off by a pin, you might not have a ground connected. You might not have a voltage connected. So you want to make sure you get that one correct. But now my lamp is done. So I'm ready to move on to the next thing. The next thing we're going to do is pump seals. Okay, now the PM kit has 2 pump seals in it and instructions on how to replace them. So what I'm going to do is I'm going to take the pumps out to replace them, because that's honestly is the easiest way. So to start, what I'm going to do is I'm going to find all my wirings that go to my pumps. You know, here's some, and if you notice, they have zip ties on them. All right. I need to snip those away without cutting a wire. So you find a good place to cut at it without cutting a wire. Boom, done. That zip tie is out. So now these are free. Now these are the sensor wires for when the pump is home. The other wires here are for the actual pump motor voltage. They also have a zip tie on them. So I'm just going to remove them. And I'm going to try to not cut into a wire. It's going to be a bad day if it does. Okay. So now these wires are free. And what I like to do is I like to find this. This is the rear pump, the back pump. I like to find those wires and trace them back to where they connect on the pump board. And I mark them with my marker, okay? So here I'm tracing back this wire, tracing back this wire. And so I'm just gonna make a mark on the connector side, just a little line. No big deal, maybe a little bit of a mark. Ooh, a lot of bit of a mark. So that's done, that's marked, so I can remove that. And I know that that sensor goes back to the one that's marked. That way you don't have to look at diagrams and troubleshoot onto schematics. Now you've got your keep it simple method. All right, I made a mark so I know where it goes back. So I'm gonna do the same thing with the pump motor wires. I'm gonna find those, which are right here, and I'm gonna trace it back, okay? So it's the back connector here. It's this back connector here. And my black marker is gonna have trouble making a mark on there, but that's okay, because I'm just gonna make a mark on the wires then. And then I'll make a simple mark on that connector. And even though it's a black marker, it shows up when you go to put them back. So I marked this one, okay, the rear pump. Sorry, I marked the rear pump wires, okay? So the sensor here and the pump motor here. So obviously the next thing I need to do is start removing things. So I'm gonna remove this wire, just get it out of the way. Yay. Front pump connects right here, so I can just go ahead and start removing that too. I can remove the sensor here. And that's not marked because that's not marked. This one's not marked because it's not marked. That's the front pump. Now, there's not a lot of space in here. And my fingers are kind of skinny, so I can kind of wiggle into things. But you may have trouble getting this last pump motor connector out as it is. I can usually get a finger in there, but if not, you can either start removing the pumps to get that out, or needle nose pliers, okay? If you're nice and gentle, kind of squeeze on there. Make sure that you're actually gripping onto what you need to be gripping onto. Sort of. See how that does. Just doesn't want to come off. All right, that's fine. So what we're gonna do is we're gonna remove this front pump, and that'll give us plenty of clearance to get at this connector in the back. And it'll give me a chance to show you on camera what it actually looks like a little better. So the pumps themselves, they mount by those same 5/16 nuts. So what I'd like to do, let's move this down so we can get a closer view. Let me bring it up a little. There, perfect. So you can kind of see one of those nuts right here. There's one here. There's one that you can't see up on the top as well. And there's going to be one on the very bottom. See this one here. One here. Oh, I apologize. There's two on the bottom and one on the top. Jeez, I'm being silly. Okay. So I'm going to start by taking out the ones on the bottom. And, you know, don't be scared to get your head down here. Now, when I say remove these, all I mean is loosen. That's a full turn. So I'm gonna do 1.5 on each. Now, this is the one that really gets me because there's this dang belt in the way. But that's okay. I'm gonna hunker down here so that I can see what I'm doing. If you have that luxury. Otherwise, you just feel for it. There it's on. So 1, 2, 3. There, that's a 1.5 turns. Now, the bottom is slotted for how it accepts these nuts and posts. The top is not. So the top nut needs to be completely removed, but you can leave the bottom 2 in. Okay. So now I'm on the top nut. I'm gonna go ahead and loosen it a couple times. But before I go much further than that, I'm gonna remove this tubing line right here. that goes to this union. And I'm going to remove the tubing lines that go to the top of the pump. This is the check valve housing. The arrow is pointing up towards this tube. Okay. I'm going to remove both of them as well. Again, you can loosen with pliers. Just give it a little pinch and a turn. And then that should come off my hand. Boom. Now, I want to keep this on here. These, pro tip, these nuts that mount to this Y here, they can be a pain. Try not to mess with them if you can avoid it. Just take out both pumps at the same time, really. That's the best pro tip I can give you. Just a smidge to give myself a little platform to set them on. But I'm going to go ahead and I'm going to work on the other pump now. So we're removing the top nut. And we need to loosen these bottom nuts. Just like we did on the other one. You don't want to completely remove. You want to loosen. Now, all four of those nuts on the bottom are loosened. I've got my tubings taken off, and I'm ready to completely remove these top nuts. Go ahead and do that. That nut is out. Set these to the side. I don't want to lose them. I keep a little baggie of these nuts when I do field work. And the reason for that is if you lose one, you've got spares. Okay, now I'm going to just ever so slightly take off this pump. See how that came out? I'm just going to set it just like so, because I still have to remove this connector, which I have clearance to get at now with my fingers. So that's out. I'm going to leave this just like this. Now I'm going to work on this one. So I pull forward, and you want to lift up just a little bit. Be careful. They can come out. Be careful of your solvent select valve here. There's these connectors that can catch on this pump as you take it out. Patience is a virtue, as I keep saying. So do this stuff slowly the first few times, and then you'll be a master. And you can do everything that I'm doing here in like 20 minutes, okay? But now those pumps are out of the way and they're ready to be serviced. So we're gonna move that out of the way. And I'm gonna work on my example pump here. So imagine that I just took this out of that unit. Let's pretend. Now, the first thing you're gonna see is you've got your check valve housing. You may have that tubing line on the underneath still, like what we had here, okay? It's fine to leave those on there, because what we're gonna do is we're gonna take this check valve housing off, okay? So in order to do that, you use your Allen head. If I can remember what size it is. I never remember what size this one is, so I always have to kind of fumble around until I figure it out. I got a good feeling about this one. There it is. So it's a 7/64th size Allen head. And what you can do now, you loosen these up, okay? Loosen those up. Okay, that one's out. the other one now. And I like to brace the check valve housing with my free hand, because otherwise what's going to happen, I'll take that last one, is it will fall forward and you could lose this O-ring and metal ring that needs replaced, okay? In your PM kit, find your O-rings. It's this big, huge bag, and there's an O-ring in here. Sometimes you have to feel around to find it. Where the heck? Oh, there it is. It's right here. So I'm gonna cut just a small piece. That way I can open it. Got my new O-ring. So the old O-ring should be able to just come right out. Now, if you've got surface tension, adhesion going from some kind of liquid on there, you can take your little flat head and just pop it out, just like so. Okay, oops, sorry, just like so. And there's a metal retaining ring here. Now, this doesn't always need to be replaced, okay? You probably have some PM kits with it in there. You might have some without. Doesn't necessarily need to be replaced though. But this O-ring, I would replace it if you can. Okay, new one's in. Now here's the tricky part. You don't want to lose these to put them back on there, because this has to all sandwich together now. Okay, so what I advise is if you have a squeeze bottle, just put a droplet of some kind of IPA or something on there, or do it the way I'm about to do it, okay? I line up the holes with the check valve sideways, and I just squish them together, and then I turn it. With my free hand, I hold it there so that I can get a screw in. Make sure you kind of keep that tension. And you want to get that one screw that you got in pretty darn tight. This one doesn't want to start. So I'll work on the other side. Awesome, that one's starting. So I'm going to get this one pretty tight, even though I don't have the other one really where I want it. The reason for that is I don't want to lose that O-ring. Okay, now I can loosen my grip and it's not going to fall off. And we're going to figure out why this one doesn't want to start very well. Inspect the threads, they look all right. Inspect the threads on the other side, they look okay. So, this going. Yeah, that's going better. Maybe something was just caught on those threads, I don't know. But all right, you want to get this hand tight. I don't have a spec for you, but pretty tight. Best I can do, okay? Now I'm ready to change the pump seal. So this is a jam nut. It's a tightening nut, and that's supposed to keep this cylinder from moving. Now, this is my example pump, so everything's a little bit loose. When you go to work on an actual pump like these that we took out, there's going to be Loctite. Loctite's a strong industrial adhesive, and we use a thread locking Loctite on this. So what you're going to have to do is where you take that crescent wrench I told you to have, and you loosen your jam nut. Now, I'm not gonna lie to you, a lot of times you're gonna have to muscle this, all right? If you need to, you grab what's called a cheater bar, and it's just an extension bar that you can put on here and gives you a little extra torque on your turn. But you wanna loosen this up. If you get to the point where the jam nut can be threaded by hand, just go ahead and thread it off all the way until it gets to the top of its threads. Now, you can either do this with the check valve housing off or on, but if you want to remove the cylinder and it's off, you can use your wrench up here, okay, on the top of the cylinder. But the reason I tell you to put the jam nut all the way is now it becomes our loosening for the cylinder because it's all the way to the top of it there. So we're gonna loosen that cylinder all the way and it's gonna slide up and off, okay? So apparently I don't have a top on here. So this is not gonna work. No problem. Easiest thing in the world. I'm gonna work on this one then. This is one of the pumps we actually took out. I'm gonna loosen that jam nut. I made that look easy. I cannot believe it came off that easy. So here we've got the jam nut on. Okay. We're taking it all the way to the top. Now, unfortunately, I gotta take off my check valve housing because I'd rather do that than take off that tubing. Now, like I said, I keep my free hand on there. When I take off this check valve housing, I don't want to lose that O-ring and retaining ring. So that's off. So we'll focus on this pump. Now, you may notice some leaking. So always wear gloves. I didn't think I'd actually be taking that pump apart. So I didn't see the need to wear it, but always wear gloves when you're doing this stuff, okay? So now to the point, yeah.
Jacques, yeah. I normally loosen those tubings on at the bottom and I leave the check valve on. Why would you suggest that we don't loosen that tube?
That's a good question. So the reason I say that is if you loosen it here on the check valve housing, the threads are very easily destroyed with this aluminum on this aluminum.
Okay.
Now, if you want to take it off the Y, that's fine too, but now you've got metal on peak material. And sometimes loosening this can destroy those threads. Now, if you're having success doing it this way, by all means continue. I don't have success.
Okay, I've always done it there at the Y.
Okay.
And I haven't had a problem as yet, but okay, I think I'll follow your procedure just because I don't want to have damages.
Yeah. Yeah, like I said, do what's comfortable for you. If you're having success, that's fine. I never do it this way just because of what I said. The threads can destroy this peak material unless you're absolutely careful and perfectly coming in. So it sounds like you're doing a fine job, but yeah, this is just the way I like to do it.
Okay. Thank you.
All right, now I'm ready to take this cylinder off and I'm gonna do it the same way I did it before. I got that jam nut all the way on, all the way up to the top. Oh. Yeah, you can feel that Loctite. All right, now slide up and I heard a pop. So the seals are probably, I don't know, those seals are shot. You can kind of see that there. There's a smoothness now around it. There's marks on it. These need to be replaced. So, come over here. My seals, there they are. So in here is going to be a new wear ring and seal. So the wear ring is the bottom part here. This is the wear ring. And this is the actual seal. Now, through the life of the seal is going to wear down. If it wears down enough, the wear ring protects it in that it keeps the metal from rubbing on the metal. Make sense? Now, the first thing I want to do is get what's called the retainer off. It's right up here. And there's going to be two flats on it that a 1/4 inch wrench can fit on. Now, this is kind of soft metal, so you don't want to try to ruin it, but you need to get that off. It just pops off, and then usually I can just use my fingers after that and finish loosening it. There you go. Now I've got the seal and the retainer out. You can kind of see there's a spring side there. The spring side needs to be facing up towards the retainer. I'm going to set that just to the side for now. So now I've got this wear ring. Now the wear ring mounts is there's this diagonal cut here. Oops. There's a diagonal cut here. And so what I do is I take my really small flathead and I slip it into that diagonal cut. I give it a little twist motion, and then I just kind of pinch on it with my finger and slip it off. So there I've got the wear ring out. Simple as that. Now I'm going to take my new stuff here. I got my bag open. And again, this is just a pro tip. I put my old stuff in the bag and set it aside. I've got to get the seal off the retainer. So I'll take my same flathead and I'll put it through the hole that it mounts onto the piston, and you just push. Okay, so don't lose this retainer, but this is my old bad screw, or sorry, seal. And there you can see the spring a little better. So I'm going to take that. I'm going to put it in my bag with my wear ring. Set those off to the side. Now, I've got my super cool new wear ring and super cool new seal. Set that right there. I'm going to start with the wear ring. And for the wear ring, what I do is that diagonal here, I get it so that it's facing forward. And then you get the back kind of on there and you just spread and move it around. Okay, then you can give it a little pinch. And then you kind of work that pinch in so that it kind of forms a little better. That making sense so far? I'm gonna give you a second to kind of look at that. Awesome, awesome, awesome. Now I've got my seal. I'm going to take my spring side, set it up. I'm going to take my retainer, okay, and I'm going to slip it through. And you want to kind of do this by hand. You don't want to damage anything. Just kind of get it slipped in there. So now you can see I got the spring side up. Everything's all sunny and roses now. So what I'm going to do is I'm going to start this by hand on the top of the piston here. Slowly start it until it won't go by hand anymore. Then you take your wrench. And again, this retainer has the two flats for your wrench to fit on. And that's when you just kind of start tightening her down. Now, I saved pretty tight on this, but you can over tighten this to the point where it starts to smash the seal and it'll spread out a little. So what you want to do is you want to very lightly get it to where it won't turn anymore. Then maybe give it another just slight tightening. Because the worst thing that can happen is it comes loose in the cylinder. We don't want that either. So now that I've got my seal on, I'm going to make sure that my travel is all the way up. And how I do that is down here at the bottom. I'm just turning this, right? And I want to do that so that the piston is all the way up it can possibly be. Okay? And the reason for that is when I put the cylinder and everything back on, I know where to stop. You'll see what I mean when I get going here. So I'm going to take this, and I'm going to do a slight little circular motion around the top just to make sure I'm not grabbing any lips of the seal. Just a slight circular motion. You can squirt this with some kind of solvent as a lubricant if you want. Again, I just do a little circular motion to make sure I'm not grabbing onto a seal. And then you just slowly work it down. Awesome. That's on there. And now I'm going to make the threads engage slowly because I don't want to be cross-threaded. It is possible. Perfect. Now I'm good to go. So I'm going to take it down by hand until I feel it top out right there. I can feel it. So right now, the top of this cylinder here, the top of the piston is hitting the cylinder. So I know my dead volume is 0 right now. But what I want is I want the cylinder with the check valve housing facing forward. So I'm going to back off. I'm going to loosen it until I get that check valve housing at that nice diagonal from the front. This cannot go straight forward. If it does, it could stick out past where the pump goes, and then your left side panel will never go back on. So I've got it there, just sticking ever so slightly to the side. I'm going to give myself a little force here, and I'm going to tighten down my jam net by hand until that's down at the bottom. And I'm going to really give it some muscle.
Judd, will that screw down any further if the piston's wound down a little?
Yes. So if your piston is all the way down, you can screw it past the point where I have it. So that's a critical step for me anyway, to move this to the top of its travel.
Thanks.
Yeah, no problem. So now I'm going to finish tightening this down with my wrench. I don't want the cylinder to move, so if it does, just kind of move it back before you do your final tighten. If you do this final tighten and it moves the cylinder, just loosen it and put it back, okay? Ooh, I like that. I'm happy with that. So now I've got a pump seal change. You would do that on the other pump. And then you put everything back together and you put it back in the unit. Okay? Some of the other things that you do in a PM are listed in the instructions that come with it. It suggests sonicating your check valves. Okay, now your check valves are obviously in your check valve housings. The top and the bottom of these unscrew. So I'm going to show you just this top one on here, and then I'm going to quickly go over the other things and we'll open the floor to questions. So boom, I just loosened that up. Just loosened that up. Notice the arrow on there. It's always pointing up. This arrow, if it's pointing down, bad. So I'm loosening this up now. And in there is my check valve. It rattles, that's good. Now the check valve itself will have an arrow as well. You kind of see that? If you can't,
Does you always check sonicate your check valves, even if they sounds good?
No, you don't have to. It's a good PM step to do though, and it can prolong the life of your check valve, but if it ain't broke, don't fix it. This sounds really good, so I might soak this in something, but not necessarily sonicate it. All right. You don't always even have to take out your check valves. If you know they're new within the last year, you can leave them alone if you're getting good performance. But for a PM, sometimes it's a good idea to take these out. At least make sure one of them rattles. If you need to, you soak them. If they're not rattling and you know you have issues with check valves anyway, take them out and sonicate them for 10 to 20 minutes in some kind of strong solvent, okay? When you go to put them back, make sure the arrow on the check valve cartridge is pointing the same way. So I'm going to slip that in there just now like this. And you can over tighten this as well. And if you over tighten this, you squash your check valve. That's bad. So okay, that's good and hand tight. So I'm going to finish it off. Just a slight tightening here. Boom, done. If you notice leaking coming out of these threads, either top or bottom, or leaking coming out through the side, that could be an indication that you have a check valve that's stuck closed. Or, you just don't have something tight enough. So there's that, there's flushings that the PM instructions advise you to do. But I don't want to waste your time by doing a lot of talking about that stuff. I would just say to read the instructions that come. And I'm going to show you real quick, the universal test mix. Oh, I got a little mess going here. Bear with me. The universal test mix will come in a vial, just kind of like so. You're going to get 4 Ready Set Gold columns for this. You're going to get 2 sizes of syringes. And these are no needle tip syringes, they're lure tips. And instructions. Okay, in the instructions, it'll show you the expected results. You want to see the pretty peaks at certain times. We know what to expect from this test mix. Okay, so that's why we advise using it. Over here, it's telling you how to prepare it. This is the normal phase preparation. Essentially what you do is you take your larger syringe, you get 4 mils of ethyl acetate, and you put it in here. Shaky, 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 till it dissolves. And then you can use that same syringe, or you can use the 1 mil syringe, doesn't matter. But then you want to add 1 mil of hexane or heptane. They're pretty much the same, but if you have hexane, use hexane. So you put that 1 mil in there that already has the 4 mils. Shaky, 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 shaky. You insert the column on the unit here. Install it right down there, and it should detect, if you have RFID, it should detect that you have an RF gold on there. Ready, set, gold. And you want to pick resolution, and all of this is in the instructions. And when it's done equilibrating, what you'll do is you'll take 1 mil of the sample that you prepared in here. You'll take 1 mil of it in your green syringe. And when you're done doing your equilibrating, you just load it on the top of the column. Just load it right there on the top of the column, put it back down, press play. Universal test mix will take about 15 minutes to run. Let's see, you wanted to see good light energy. So I'm going to turn this unit on and show you a couple things there. I will show you how to reset the pump strokes, but I'm open now to questions if anyone has any.
Yes, Judge Jock again. On the test mix, the peaks, I've seen that they don't come out exactly the same timing or the same size on certain instruments as what we see on the paperwork sent with it. Is that a problem?
No, not necessarily a problem. If the peaks are coming off at any point in time, I don't want to say that's a pass, but it's encouraging. Now, there could be things where like your gradient is slightly different than what it's exactly supposed to be, but you could have a flow rate issue. So if that's the case, I would do a flow rate check. And how I would do that is I would just put a collection beaker right here, run the thing in manual control, a flow rate of like 20 mils a minute through column and flow cell. And then you look after 3 minutes, do you have 60 mils inside your collection beaker? If you do, then your flow's right. So then you start to wonder, did maybe I get all my sample fully dissolved? Sometimes when you inject in here, you might have some sample blow out as a powder.
Okay.
Little things like that can affect your chromatography. So they're not going to be perfect. The universal test mix will not be perfect, but we do have a general area time frame that we're looking for these peaks. You may notice that the intensity isn't quite as pretty as it's supposed to be on here as well. I don't have a spec for the intensity, but we do have optimal results that we would like to see.
All right, so if we see the peaks come through and the timing slightly off and the physical size, it's not something to necessarily go and worry about.
Yeah, that's a good rule of thumb to follow. Now, if your peaks are really broad, that could be an issue.
Okay.
But if they're off by 30 seconds or something like that, or they're not quite as intense as you would expect, it's not a showstopper.
Okay. No, great. Thank you.
Yeah, no problem. All right. See my assistant in the reflection there. Give him a wave, Jeff. Hey. All right. So we're going to turn the unit on. Ooh, did you see the arm move? Probably didn't, but it's homing. It's turning on. Any other questions while we're waiting for this to boot up? Awesome. Now, if you're following along closely, you'll remember there are no pumps installed in this unit, and yet it came up as idle. I did that on purpose. I want you to know that that can happen, okay? This is saying that the solvent level sensing isn't detecting any solvent. That's fine. I don't have any solvent that the inlet lines are in, so I'm not worried about that message. Okay, so here we want to start checking some things. So this is the manual control screen, and this is the bar that I was telling you about down here. Now my lamp just fired up, so let's give it a second here. There it goes. Holy cow. All right. So as you may be able to see, maybe, yeah, get it as close as you can. Awesome. There you go. So this bar graph down here is what I was talking about. So at this very end here is the red section and the rest of it's green. Now, if you notice, the indicator is all the way to the side. I don't know if you can see that or not, but you'll see it on your units, okay? This is very good light energy. There's one other place that we can mess with it though, and that's in the service menu. And the password to get into the service menu is CombiFlash. Loading service screens. Service menu is a great place. There's an entire section in the manual dedicated to it, whatever screen does. I'm just going to super duper duper quickly go through them. The other ones too might be better. Let's see if it'll stop washing out. All right, so it takes you to the detector screen to start. And something you'll notice here kind of at the top, vapor. I don't have a vapor sensor installed, so it's maxed out. Don't worry about it. It's fine. But here's where I was talking about. You can turn the lamp on and off. This is actually a bar graph showing you, well, not necessarily a bar graph, but it's a graph showing you what the light intensity is. And so I have my integration time up here set to 2. Okay, my wavelength is set to 254. I can turn my lamp off if I want to, but it's giving me a lamp energy reading. Now, if your integration time is set to 2 and you're over 4,000, you're good. Holy cow, is that good. Well, let's mess with it, see what happens. Let's change this to 10. And it's still as high as it possibly can be. Down here is a resistance, or sorry, absorbance. It's an absorbance meter showing you what spectrum is being detected right now, and it cuts off here at about 460-ish, but everything else is pegged. Your light energy at the top is completely maxed out. You couldn't ask for better light energy. If I set this to 10, I'd like to see above 6,000. That makes me nice and happy, but I don't have a spec to give you other than You just want to make sure on these two that you're getting good detections on your graph. So we'll set this to the 40 like it talked about earlier. Holy cow, even better yet. Look how sharp that drop off is now. You can't really see it, sorry. But we're still all maxed out. We're still over 8,000 for lamp energy. So that's a good one. Now, if my ELSD was still installed, we could do stuff on this screen, but this is the ELSD screen where you can check your temperatures. You can check what the temperatures inside everything is. You can manually turn your gas on and off, your laser on and off. You can just prime the pump of the ELSD here, and it gives you a detection level as well for the ELSD, just like we saw over here for the detector. It's doing the same thing for the ELSD. So you can tell if there's, you know, crazy spikes going on, because obviously right now I'm not running anything. So it would tell you if there's something going on with your detector. MS is for a mass spectrometer. The only thing you can do here is load or export tune files. We're not going to go over that today. Fraction collector, here's where you align the arm. It's all in the manual, but here's where you access it. And you're going to go back and forth, left and right as you align your arm. Pumps, here's where you reset your pump stroke count. Holy cow, I'm only at 400 strokes each, but I just replaced my seals and I'm going to reset my pump stroke counter. So that went from 400 strokes each to 0. And as you can see, the strokes until replacement is 200,000. We talked about this earlier. So when it approaches, say, 150,000, it's going to start throwing up warnings. And if you exceed 200,000, it's going to tell you to contact us. You can turn your fancy lights on and off for the unit here. So I've got my red light, my white light. Let's see, there's the red light. You can play your sound. Whoa, that's super cool. All right, now you can go over here to solvent supply if you want. This tells you how much solvent you have in here. You can start your air pump, make sure it's working. You can stop your air pump. You can zero all your pressure transducers, but I would only do that if you remove all your solvent sense lines first from the back of the unit. Moving on, I've got column here. This just tells you what column is installed. So let's see, I've got my RF, my ready set golds here. So let's see what it does. I can read through the baggie, which it can't. So take it out. So it's not reading the column at all. I know these columns are good. So that tells me I've got something going on with my RFID in my unit. Well, fancy that, during a training, we just learned a little bit of troubleshooting. That's pretty fun. But anyway, it should say something here like 12 gram ready set gold, if it was working correctly. All right, now, firmware is the last screen. You can set your warranty date. Don't change the serial number. Don't even look at that. That doesn't exist up there. Don't change that. You can set a warranty period, and you can actually set a reminder here for your next PM. So if I come in or someone else comes in and does a PM on something, the customer or I can talk together and we can tap this, and I can just say, you know, 12 months from now, I need another PM, and I'll hit save. Simple as that. But that's the service menu. To exit out, you can hit exit, or you can just hit the power button to turn it off. Either way you slice it, the machine's got to reboot. So I'll just hit exit, hit yes, and it'll reboot. So that, in a nutshell, is my presentation and training for the day. So I'd like to open the floor back up to anyone who has any questions.
Judd, Jacques again. Just
Yeah.
on the lamp there in the service menu, I found that when you turn the lamp off, I can see it that the energy drops.
Oh yeah.
try and turn it back on in there, it doesn't respond. I have to reset the instrument and then the lamp will come back on.
Interesting. I don't
Yeah.
usually have that problem, but I can look into that for you. I'm gonna make a note on that one.
Okay. What I'll do is I'll pop you a mail with the serial number. It's a fairly new instrument. It's about a year old. So it was the first PM. So, and I found that when I turned the lamp off there and I turned it back on, the energy didn't go up. I had to reset the instrument and then it would come back on.
Oh, there is a small delay. We'll do it here on this one real quick.
Okay.
Yeah, when I say small, sometimes it's not so small. It's a long
All right.
but light energy not returning. All right, let's test it out. All right, I'm loading my service screens back up. While that's loading, anyone else have a question? Awesome, awesome. Okay, so right now I've got my lamp on. I've got a reading right now of lamp energy. So the question was, how come my lamp isn't turning back on after I hit this button, which I'll do now. Now my lamp just turned off. My detection spiked here, and that's because I'm actually picking up ambient noise from the room around me. My computer screen, the LED indicator from my camera, but the lamp energy is gone. It's gone. So what I'm going to do is I'm going to turn my lamp back on and we'll test what Jacques was talking about. So my lamp hasn't turned back on yet, but I can see an orange glow from it because these lamps do have to turn on. They have to warm up before they can turn on. So I'm going to give it another second or two. There, it turned back on and my light energy returned. So all in all, that was about 5 to 10 seconds. So let me know if you are not noticing this on your units. If you're noticing that lamp energy doesn't turn back on, you may have to remove the left panel just so you can get eyes on the lamp itself. Does that make sense?
Yeah, so I'll do that.
And I don't doubt it that maybe you have a unit where it doesn't come back on. So send me the info. We'll talk about it.
I will do that. Thank you very much.
Yeah, no problem. All right. Any other questions from the group? All right. Well, then I'm going to go ahead and give closing remarks. I want to say thank you to everyone paying attention, being so nice to me today. I hope I gave you everything you were looking for in this training. But remember, another thing that we want to discuss is what kind of training are you looking for? So everyone should have my email from the Zoom meeting, request. So if you want, go ahead and shoot me your ideas. This is the training we're looking for. We'd like more information on this. Is it possible to do like 5-hour training session on just the flow cell, something like that? Whatever ideas you have rattling around in your head, just go ahead and shoot me an email. But other than that, I'm going to say thank you. If no one else has any questions or comments, I'll let you sign off. And if you have anything further, you can email me, you can call me. Otherwise, have a great night.
Yeah, Judd, thank you. It's Philip here. Thanks very much on behalf of everybody for all your hard work. I would ask if people are going to email you with suggestions, perhaps they could copy me in as well. And
Good
also, I guess what I would say is the suggestions, if we get lots of suggestions, the ones with the most popular ones are probably the ones that will get prioritized. But yeah, also any feedback on this style of training. A couple of you have sent messages already saying that you think it's quite useful, even if we get back to real training in the flesh. These could be still useful, but yeah, just give us your feedback, please. Thank you very much.
Yeah, good point. I should have mentioned that. Apologies, Philip. If you have any of those suggestions you want to send me, just make sure you CC Philip Moss, okay?
Thank you. I don't want to get left out, you know.
No problem, no problem.
Thanks a lot.
Yeah, no problem. All right, well, thanks, everybody. Have the great rest of your
Thanks.
day, night, or whatever the situation may be. Until next time, I'll see you later.
Bye, thank you very much, Jude. It was
Thank you.
a
Bye-bye.
very good training.
No, thank you. You're too kind.
Thank you very much.